Questo non va? Sì, eccolo, sì, 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 sì.
I'll be using this one. Yeah, I'll be standing. I'm just more seeing now, so.
Io lo accendo di già, eh? Io lo accendo, quindi ora semmai si fa un attimo il check.
Test.
Io?
Test, test. Okay.
Sempre andare con la presa, no? È accesa la presa.
So a little intro about myself. I'm from Bolivia. I pretty much grew up there, and I'm living now in Chicago. For no one outside of Chicago knows the flag, but that's a Chicago flag, and it has probably one of the few states that has their own flag that even the local people know. Other ones they don't even know it. I'm not a typical software engineer. I actually did economics and statistics. Now more data science, but I also do a lot of data engineering and infrastructure for it. I'm a big fan of tech meetups and events. That's kind of why I'm here myself, and for the community. And that was on PyCon 2023, US, Pittsburgh. And so some random question, does anyone know the name of the current keyboard, like the layout? QWERTY, yeah. But the actual history of QWERTY, it's pretty old at this point. It's tied to the typewriter, and this is the first commercial typewriter, which looks probably harder than any keyboard that we're going to be looking down the line, because it has a lot of different layers. And this was by Carlos Gliding and Scholl in 1860s, and it was actually a wooden box, but if you see on the back, you can see the mechanical parts like the typical typewriter, but this one has significantly way more layers, and it looks more like a piano keyboard than an actual computer keyboard. This is how it looks, the wooden box itself, and you can see that the typing was done inverse at the bottom, in the flat part on top. But going back to a more normal looking typewriter, this is from 1926, so it's almost 100 years old. And you can see the mechanical keys on top, and this was a portable one. That's kind of why it has like a box on top. But if we take a closer look, if the keys are pretty much familiar to what we're probably using right now on our laptops. This is today's modern keyboard. I'm not sponsored by Logitech or anything like that. I just chose this one for the sake that the keys are round. And if you look them like next to each other, pretty much 100 years apart, they both look almost exactly the same. You probably add the function row and the navigation, but everything else is the same. Like we didn't even have like monitors then, let alone computers or quantum computers or LLMs or anything, and yet we're still keeping such layout. So this is the modern full-size keyboard. Probably no laptops have it, but if you have a desktop keyboard, you could use this one. If you have a lot of like number navigation, a lot of people prefer to have the numpad. But let's see what we can change we can do. And all the images and sources will be on my GitHub, and I'll post it on LinkedIn. So this is the full-size keyboard again. There is different parts of it. We see the number row, the function keys, the numpad, the navigation cluster, and the arrow keys. But we can start actually removing some keys, and you probably already do in your laptop because most laptops, again, don't have the numpad. So this is the TKL, and this one pretty much just removes the numpad itself. So most desktop keyboards look like this. And then we can keep going down the rabbit hole. This is a 75% keyboard, and it slightly shifts the navigation. And this is what most laptops look nowadays. Some of them have like the bezel keyboard, which is like slightly separated, so it's easier to navigate with a tactile function, versus being everything like the top one. And then we can keep going. Then on this one, we're removing like the function keys, and like a lot of laptops also have it. And if you have like pretty much your phone, if you hold like then you start introducing the layers, and we already use a lot of layers. If you use any function to increase the light or dim of your computer, as well as volume, you're already using it, as well as any special characters. You use either Shift, Alt, or Control. This is 60, so it's pretty much the same, just without the arrow keys. And a lot of gamers already use the ASDW for moving around, so that's kind of proof that the arrow keys are not always necessary. And then we can keep going to 40%. So this one introduced, as you can see on the sides, more function keys, and you can see the colors on this one. That's why I chose this one of what each key does. But then it tends to the point of like, is it enough? Like how far can we go, and is it worth it? So that's not enough, because we can keep making changes. The current keyboard is also row staggered. It has like slightly diagonal shift on the row, and it kind of makes sense for the left hand, but it doesn't for the right, because fingers move up and down. However, the row stagger makes sense for the left. Again, the right is like the opposite side. So even if you put it on the proper home row, yeah, this would not be ideal. So even if you discard everything and just keep the ortholinear, it's already better for your fingers. And this one starts to introduce a bit more of like thumb keys, which we'll talk later on. And again, ortholinear applies to everything. You don't have to go to the smallest keyboard to start using the ortholinear. You can still have a full size and be ortholinear, so you don't have to commit to all or nothing. Then if you go ortholinear and small, there's a new issue, which is the wrist position can be very painful if you type for long times because it's very compact. So now we're starting to implement a new option, which is splitting keyboard. And the idea of the splitting the keyboard is that you can have it at your shoulder level. You can have your coffee, your cat, everything in between. Anything you want, your charger. Just be careful with spilling the coffee. And the good thing is that it can be the shoulder. It's more comfortable. This one is wireless. That one uses a different software than the wire ones. Again, you can tilt it to the hand position. So even though it's ortholinear, now you can actually tilt it to the proper way of the hand, the hand movement itself. The good thing of this one, and actually on this one, it starts changing. This is also ortholinear, but then the changes are more vertical. I personally have a super small pinky, and it's crazy that nowadays we use pinky for pretty much all the functions or control or layers. And this is the reason why changing the levels of the keys vertically makes more sense because our fingers are not the same length. And also the thumb, which is the strongest finger in the hand, is only used for spacebar and not only one thumb, both thumbs. And it's kind of a waste of the whole thumb for just that. So then that's kind of why you start seeing all the navigation and the functions on the thumb. You can have the control or enter or shift or any command that you want on the thumb. And the thumb starts, you can go crazy with the thumb. I prefer to keep it for 3, like this one. And that way you can navigate more easily. And then you can make them fancy. This is wireless, and it also has like display screens. And this one has the QWERTY layout, so you don't have to change the layout itself. But then you can go crazy with the keycaps. There is some crazy artwork and crazy expensive ones as well. And this one starts to be a bit trickier because the commercial ones, if you do these ones, are crazy expensive if you buy like that. So that's kind of why this is the same but wired, and this one has encoders. And the good thing with the displays, actually, if you're new to them, is that you can see which layer you're navigating. If you have a big one, it's not that relevant, but if you have like the corner, like the 40% one, it starts to be very helpful because you can see if you're in the function key and the number in navigation or number key. This one has the numbers, so that doesn't apply, but that's more for the corn. And again, the encoders could be for volume, light. So that's why I was saying that they're very expensive if you buy them, but you can build them. This is the Lily 58. That's an open source one. Some companies do sell the PCB, but you can order and make the PCB. You can order the PCB. I would recommend that first versus designing it. And you can, there is a bunch of layouts of the open source one, and you can see what fits your hand or what's comfortable to you. Because again, there's so many different options where like just the thumb keys are slightly different. Because they're all open source, they're very tailored to their own needs. And that's the good thing about it. And even if you find something that you like and you want to change it, we're going to talk about it later. This is just the PCB itself. And this one is a through hole one. So you pretty much put all the key and components for every hole. That's why it looks kind of like crazy amount of holes. And these are all the parts that you will pretty much do it. It has like, I'm not sure if anyone has worked with electronics, but it has like pretty much the holes for the diodes, the hot swap sockets are recommended. You can pretty much put the keys directly there, but if you ever want to change it to any different type of key, mechanical key, you can do it to like go clicky or linear or any option. The Tiara jacket on mine is wired, so I chose that one, but there is the wireless ones, as well as the connecting it to everything, the USB-C, and then we also have like optional things like adding the reset button if you want to reconfigure or flash it. And at the end of the day, you can add, of course, LEDs like any keyboard crazy fanatic. And the idea of this is that it's pretty much working. This is the building guide that I just showed. That's the Lily 58. I have a slightly pivoted version of that one. But that one has like super details about it, about how to solder everything and put the pieces together. And there's a lot of Discord channels that has help. Even like if you go to this one, it's like Chris Cables has their own Discord channel. So if you run into any issues throughout the way, you can ask, and there's always people helping. And they have different models and different options that you can go through it. Again, that's the one I just showed. But I found I'm building one guide, but that's one of the most helpful guides I've found overall for keyboards, even if you don't opt in for that layout. But then, as any programming, once you find something online, you gotta transfer it to what are you trying to use it, and make it useful for yourself. And how it all works at the end of the day, it's just pretty much an Arduino. It's a Pro Micro. You can use the RP20, 2040, and they both work the same way. Again, this is more like a close look of the keyboard, and I do recommend to do the sockets for the Arduino, so in case something goes wrong, you can easily replace it. Or even if you stop using that keyboard, you can reuse that Arduino for something else. You can even insert the like super small batteries in between the socket and the Pro Micro and make it wireless, and they last about like a day or two if you have no display. With display, and if it's OLED, I would recommend not to have the battery, or unless you have a very big button at the bottom. This one has the OLED, but there is also there is one that is like a paper ink, like Kindle, that one's super efficient for battery. Now we're gonna talk about actually like building the layout. And this one is, I found this page super helpful because like it kind of shows all the stats of how any layout that you choose. Like if you choose QWERTY, you can see pretty much all its stats and the benefits of it. The second most known one is the Dvorak, which is from 1930s. So that one was a 12-year elaborate research in English, actually. You have the vowels and punctuation on the left hand, and that makes the navigation easier, and you can see the efficiency and effort are highly better than like in the normal QWERTY. Then you have other way more options. The current one I'm using is like Comac, which is a deviation of Comac, which is the second, like Comac, I think Comac DH is probably the third one most common. But of course, all of these ones would take time to learn. And even if you want to go and customize it to any language, I found this page, which I have the QR here. Oh, here. I was talking about layout. So yeah, this is the Dvorak. It's against the 1930s, so there's actually some typewriters that already have it, and most phones, even iPhones, have the option for the Dvorak. I haven't met a single person that uses it on the phone or tablet. I think it's only computers. That would be a whole different level, but you have the option to do it. It limits more to random layouts, and that got mixed up, but this is the efficiency of the Dvorak, and you want to stick to the home row, and that's kind of why it's more efficient. This is a heat map of the keys that you use the most in English, and that's kind of why the Dvorak is based that way, and this is the Dvorak layout itself. That's the slide I already saw, and this is the other one that I like a lot because you can just drag and drop and see for any language the efficiency of it. And on this one, like this is like, for example, one of Italian, of course, you can see that it might not be the best layout, and it does change accordingly. But the good thing about it is that if you want to change it to the Dvorak to test it, it's like a drag and drop, and the stats refresh according to the language. So that's why I found this one helpful. So now that we're doing all this, how we get it to the keyboard that we made, you gotta flash it. The QMK is the option for the wired one, and you connect it with the RRS, which is, it looks almost exactly like the audio cable. It just has the 3 lines instead of 2. And you will flash it, and again, like if you do the open source way, you don't have to reinvent the wheel. There's so many options. Like if we could look at the corn again. And this one you can see, and this one you can also customize it here and drag and drop the keys, and you can see the different layers and what they do. Now, you will download it and flash it, and it's pretty straightforward. Now, you can also do it actually on any editor. I'm sorry, but this one is not on Python. You can do it on C or JSON. And here is the one that I currently use. I actually have the option to use the Hallmark, which is the layout that I preferred. And the QWERTY and different layers. So the comments are more for my own sanity to review what I'm doing and keep track of it, because otherwise the changes can be crazy. And this is the QWERTY, and this is the Hallmark, so you can see some differences on them. And you can see that the function keys at the bottom are different, and we're starting to make the most of using the thumb This one here is actually the encoder. It's not a key in this case, and that's why it's showing that one. So if you want to design it from scratch and not use an open source one, you can do it on Python. There is actually GDS Factory. I found it very hard once you start not making symmetric figures. Like you could probably get away by making something like this. This one has an encoder and 6 keys. Like even if you want to do a full keyboard but be ortholinear or like symmetric, it's pretty straightforward. And you can see these ones on the back, still see the Arduino and everything. But once you start to make like the keyboards we saw, I found it very inefficient. So I kind of pivot from that one, but you can use KitKat. It's an open source. It's great, and I haven't found any issues. Like fortunately, I was able to use Fusion with AutoCAD, and I wouldn't say it's more easy to navigate, but I don't think it's drastically better. And that one is like significantly more expensive, like any AutoCAD. And so now that we're happy with the layout, we gotta pretty much learn how to type again, because that's a whole new journey. And there's a lot of different sites that we can use that, and they allow pretty much for you to choose the layout that you want to play with. These ones are very good for query layouts, even if you want to increase your speed. And these ones are more that you can tailor to more indie layouts. Like the main ones are there, but if you want to kind of make your own again, I found this more helpful. However, we can actually make it on Python and do the testing on Python itself. So let me see if I have it open. Hopefully it works. And on this one, we're using Pygame. Let's see if we can. And what I actually did for this one is I selected a folder, and based on the commands that I use in that folder the most, is going to give me the words. So it's not only making me practice, it's making me practice to actually, it's not this one. This is more a general one. Sorry, I can go the other one. But of course, typing. Oh, I just missed the percentage and speed. But let's look at the one that matters more, which is this one, because you can actually see that the commands are based pretty much on the code on this folder, which they're not going to be like normal English words, so you can choose it to tailor to anything. And let's just do 4 words for. So clearly this is no longer typical practice. Hopefully, there you go. So, and you can change it however you want it. You can base it on the GitHub and extract it and use those words. And at the end of the day, you're making everything more relevant to your own experience and what you type the most. These are the libraries that are used among those. They're not just used for these, they're very helpful for pretty much any random pop-up that you want to play with. So there is still a lot more that we're not talking about. Like pretty much all keyboard fanatics are it's very polarized about like keyboard switches. If you want to go linear, tactile, clicky, even the keycaps again, all the artwork on it. But changes take time. So I put this here because like if anyone has ever like done like straight razor, it's not the easiest transition, but that's once you're good at it, that's why barbers prefer it, because it's more detailed and they got used to it. Now, if you're in a rush and you have a lot of work to do, probably it's not the best idea to be making all these experiments on your own. And that's why I chose that one. So not fully convinced. You can start by making small changes. You can use the increasing speed sites just to whichever language or keyboard layout you have and do it that way. There is also, again, you can just do the ortho and or the ergonomic layouts, as well as like changing the layers and playing around to having shortcuts yourself. So maybe then you can like start to soldier yourself one of them. You can send them to PCBWay, like the design, and they'll print it pretty cheaply, or you can also get it from the sites like the one I show on the guide. And then maybe start playing with changing the layout once you started based on something like the sites I showed. So if, you know, and even if you want more, again, I'll focus less on the keyboard switches and keycaps, at least myself, but a lot of people, that's the reason they love their own keyboard. So of course, feel free. Again, these are more random products that they're already helpful and you don't have to go crazy on it. I used to have this one similar like this one for like 4 years, and I really love it because it very much forced me to use the hands the right way of using the left and right for each key. This is actually Lex Friedman's keyboard, Kinesis, but that's what I'm saying. This one's like about $400 versus if you make something, it's gonna be like closer to 100. It's still not cheap. It's like 100, 150 depending. And this is one that my friend made actually. And the benefit of it is that he has a trackball on it. And even though all of this might sound like just like spoil, I want to make my own, it's very helpful if there is some conditions that, like at some point I did fracture my shoulder. So like going back and forth from the mouse was a pain. So having something like this is ideal. So it's not just necessarily something that, oh, I want to be more efficient. You can tailor to whatever you need at the end of the day. And if you thought this was crazy, then of course there is even more options that it's a whole rabbit hole, like I mentioned at the beginning. I would say like join your local keyboard. Again, that's why the only reason I showed the Chicago flag, because I did join them, and like all the Discord, there is also a lot of people that have passed through this, and they're always happy to help. And even if you want to trade or work with anyone in person, it's always helpful. So yeah, I would just say that the conclusion is actually from a YouTube video that I watched, is the tools we use are not always the result delivered design for optimal efficiency, but rather the outcome of historical process and practical necessities, which is pretty much why QWERTY is where we use it. It's just a legacy, and pretty much people don't question it and just defaulted to keep using it, even though it was meant to prevent jamming and reduce the keys that go together, like the letters that go together, to be next to the keys. But we just kept that idea. So thank you.
Thank you again. No question on Slido, but I don't know if there are questions from the audience. Oh, okay. One question?
What about using a custom layout on a laptop?
That, I would say, depends on the laptop. If you're using Linux, it's way easier than if you're using Windows or Mac, because sometimes you, again, like you depend on the software, like the iOS itself. So you could do it. The only thing that it can start to be tricky is not confusing yourself with the keys that you already have there. So as long as you get past that, it's fine, yeah. And that's like a. Some of them have it like built in. Like if you go into the settings and look for the keyboard itself, you can change it there, and that applies to phones too. So. Exactly. You cannot default to whatever computer you're using, like the Vorak like example in that case. So that's the good. Also, that's the good thing about using a Pro Micro, is that no matter what computer you plug it in, you can have any shortcuts or layers. It's always gonna work because it's doing its own. So that's something that I found very helpful. Because if I also recommend to not change the layout on your laptop. I did change it on the split keyboard, so that if I'm ever working on a laptop or someone else's laptop, I'm still functional. I don't want to be taking forever to be writing or like be fully inefficient at the end of the day. So that's a good point, actually. Because that way, the brain remembers that the split keyboard is different than the normal keyboard. Otherwise, it's very hard to separate.
Any other question?
Yes, but again, this is like the one I made. I changed it to QWERTY in case anyone wants to test it. And I live in the US and I brought it here. It's pretty compact and portable. I like the case that you can steal some of the switches on the back. And again, this is the wire version. I changed it to QWERTY because the layout I showed is not that one. This is one of the pages that I just downloaded. And it of course has all the fancy lights on whoever built this one. But I don't like that display on the default of this one that I download from the QMK. Doesn't use the display because it would be useful to see the layers on the display, like I mentioned. But I can plug this to my work computer, my Mac, and it always works. So you can have one at home and one in the office, which is what I do. I just leave the one in the office there and have this one. This is the office one because it's more compact than the one at home. And that way you can always use it. And the only thing that I would recommend against, if you work with anything on IT that you always gotta be on someone else's laptop, like fixing something, then of course not. That's probably not ideal. And like I mentioned before, it's not like you have to do all or nothing. You can take small steps and change the layout, change the keyboard, make it ergonomic, just make it ortho. Like you don't have to do all or nothing, and that's what I like about it.
Basically, every time you leave the house, you bring your smartphone and your keyboard.
No, that's what I was saying. Like to the previous question, like I still have my laptop fully normal QWERTY, and that's kind of why I only use weird layouts on these ones, because at least for my brain it was easier to adapt to that one, and yet still, that's why I mean my typing skill on the live test wasn't anywhere optimal, because I can still do it, but it's not ideal anymore.
You mentioned that you can use QMK for wired keyboards. Are you not able to use QMK for a wireless keyboard? And how would you put it in a wireless keyboard?
Yeah, wireless, it's CMK. If I can spell. If I can. Yeah, so you would approach it with CMK, which would be this one, and it's pretty much the same process because you can use the nice tools like I showed, but the editor one transfers equally to both. You just need like the flashing way to be slightly different. And again, if you want to use like a e-ink display or OLED, those things get changed in the config file, and you pretty much make a zip folder and drop it to the Arduino, and that will take care of it. That's why I recommend adding the reset button. If you ever, like, I just changed this one before, like 2 weeks ago for a different talk, so that people can use it the QWERTY way and not like my weird layout if they want to test it. But yeah, it's pretty straightforward. And once you have it on the computer, it's pretty much connected, reset, kind of like flashing, like adding a file to a USB-C.
Okay, we still have a couple of minutes for some more question, if anyone have. Okay.
Is there a chance that you build your own keyboard and that will cause more injury to your wrist than regular ones?
Yes, that's why I show the example of the very tight ortho. Sorry, almost there, this one. This cannot be good for the wrist. Might be good for being portable and still having your own shortcuts or custom layout, but I don't think it could be good for wrist by any means.
But I was also thinking to split layout keyboards.
Mm-hmm.
If you build them, I don't know, with a size that does not fit exactly your hands and fingers, you can cause yourself strain by reaching
Yes.
the keys.
There is
I
this.
saw people struggle.
No, there is this site. I didn't put in the slides, but what I did is like it has like the layouts, like just like a print version of this. No need of the inside or anything, and you can print all of them and see what fits best for your hands, and which is what I did, because this, like I mentioned, is a deviation of the Lily 58. But like I mentioned, I have the shorter pinky. That's why these two rows are shorter, like lower than the Lily 58, which is another popular layout. And it was by printing them and like playing with that paper and what makes sense to my hands. So I would recommend that, and I also recommend buying like a cheap soldering kit if you're gonna make it yourself, because you don't want to buy or order a PCB and be waiting for it to arrive, and once it arrives, it's your first time soldering and ruining it. So I would recommend buying a $5 cheap soldering PCB board, and it usually comes with big and small parts, and that way if something goes wrong, it's not catastrophic as like if you do this, because I did a different layout keyboard the first time and it went wrong, and undoing is way harder than doing it right the first time.
Okay, no, sorry, no more time for question, but you can follow up after the talk. So
Yeah, feel
thank
free
you
to
very
find
much.
me after anywhere.
Okay, thank you very much.
what I was wondering is I'd love to take this keyboard here, be able to pull it out.
Secondo me c'ho il telefono vicino al ricevitore, al trasmettitore. Lo fa? Fammi sentire. Sa, è vero. Aspetta, è vero. Però sono lontano dal trasmettitore, eh? Da qui lo fa, eh? Sì? Prova a cambiare le batterie. Magari non ce la fa a tirare. Ora? Ancora?
Not got the framework on it. Framework has their own layout or their own design file in JSON that you can import, but
Yes, you use JSON for it.
sorry.
You use JSON for
Yeah.
for flashing it, so you could do it.
Okay.
Like now, designing that part and have it printed by PCBWay or whoever, I'm not 100% sure. You might be able to change the keys itself.
Ma come possibile? Allora è un problema logico, cioè, allora è il cavo, non so che dirti. Prova a scambiarti il cavo un attimo. È questo. È questo qui, te lo cambio, aspetta. All'archetto. Ciao. Ora però sta cambiando. Ora lo fa? Sì? Mi legge l'altro. Non so che cos'è. Sì, no, c'è un disturbo, ma non capisco perché. Ah, ok, ok. Thank you. Sì, sì.
Hello, everyone. Now we have Marc-Andre Lemberg, and he's going to give us a talk about programming hardware displays. And have fun, everyone, and good luck.
Thank you. Thank you. So yeah, today we're going to do something different compared to what I normally do. I normally talk about architecture, you know, cloud stuff, all this big kind of picture thingies. And over Christmas, I decided to have a look at something that's very tiny, so embedded displays. And I wanted to use MicroPython for this. And so I sat down and then tried to find a nice project. So who am I? I am Marc Lemberg. I've been around for ages. You know, I've been there ever since Alex Martelli, who's sitting here, came to Python. And I've done lots of things in the community and don't want to go into details here. I also have a company doing consulting in, you know, Python projects, of course. We have a user group meeting in Düsseldorf that I run as well, together with my co-founder, Charlie. So what's the use case that I wanted to do for this particular project? I'm one of the organizers of the Python dev room at FOSDEM. And so for FOSDEM, we typically have a very, very tight schedule because everything, you know, has to start and stop on time. And so I was thinking that, you know, maybe to help the speakers a bit, I can create a talk timer for them. Basically putting all the experience that I have with giving talks into this kind of little project, and also being aware that, for example, you cannot really, you know, read what's on the display there, so you have to have some visual indications as well of how far you are into the talk. So I wanted something that's cheap, I wanted something that runs on batteries, I wanted something that is bright enough as a display to actually, you know, be seen. And I wanted to make it so that you can easily program schedules into the talk timer. So, for example, I have put the schedule of PyCon Italia into the device now. And what you're seeing here, so this is the thing that I'm going to talk about. This is actually running on the current schedule for PyCon Italia. And we're going to see how that works, how you can make that work as well. So first, of course, you need the hardware. I was looking around for a display and something that actually runs MicroPython, and I found this the cute little device. It's called CYD, for cheap yellow display. Yellow because the circuit board is yellow, right? Display, of course, because it has a touch screen. TFT display, and it has an ESP32 microcontroller which can actually run MicroPython. As you can see, there's not a lot of RAM available, so sometimes you have to be very, you know, aware of what you're doing. Unfortunately, they put a low-spec ESP32 on that board. There are other ESP32s that have, you know, lots more RAM, like 4 megabytes, for example. But I haven't found a version of that particular display with that, you know, larger ESP32. It's very cheap. You can order it directly from China for €8 a piece, or you can get it from Amazon locally, and then it's like €23. So depends on where you buy it. You can very easily get these things and order lots of them. So in terms of software, what do you put on these devices? Of course, I wanted to use MicroPython for this. How many of you know MicroPython? Just a few. Interesting. So MicroPython is a project by Damien. He started Damien George. It runs Python 3 on microcontrollers. So ESP32 is a microcontroller, and it's amazing what he did. I mean, how much functionality he put into that tiny project that you can actually run on these small devices. It comes with lots and lots of hardware interfaces. So SPI, for example, is one that drives the display. And it's very easy to flash on these boards. So you can get lots and lots of different boards. And then you typically just have an ESP tool, it's called, and you use that to flash MicroPython onto the device. And then for graphics, I wanted something that looks really nice and professional, so I had a look around and I found this LVGL, which is a library for embedded devices. It's open source. There's support for MicroPython available. And as you can see here, it has lots of widgets, so even including a keyboard, and you can do graphics, you can do tabs, you can do entry fields using the touch screen. So it really kind of works like a mobile phone, except that the hardware specs needed for this are a lot lower than for hardware for a phone. So I wanted to use those two things. Now, next thing is that you have to program these devices, right? So it's not necessarily straightforward on how you would do this, because you have to get the software onto the devices. Typically, what you do is you use a USB cable and then connect it to your notebook. And I tried lots of different ways of doing this in a good way, and tried the different IDEs that were available. So I tried Tony. How many of you know Tony? Few. So actually, it turned out that Tony is the best IDE. It's not perfect, but it's the best that you can use for these devices. It's also possible to use the Mu editor that Nicholas wrote. I don't know if Nicholas is here. No, he's not. And I also tried, of course, Visual Studio Code, because that's what I normally use for development, but it turned out to be way too complex to set up and didn't really work that well. So Tony is open source as well. You can just download it, and then you see the interface here on the right. So if you want to start into this, of course, you need proper documentation, right? Now, the documentation for MicroPython is excellent. The documentation for LVGL is excellent as well. Unfortunately, only for the C API of LVGL, not the MicroPython port. So, yeah, I mean, finding something that actually works with both is a bit hard. They do have some examples in the LVGL documentation that you can use to basically drive into this. There are lots of examples on the net, and what I did is I basically used Perplexity AI chat to just, ask it to find the resources, because it's so much easier than manually digging into all these different resources and finding them myself. So I just asked Perplexity, okay, can you show me how this is done? And then it came back with code, and I tried it, and usually it worked. So that was nice. That was actually the first time I really used the AI chats for doing these things, and I was surprised on how good they were. So yeah, getting things working is moderately easy for getting the software working, the main part. Driving the display is easy as well, because the port actually comes with proper support for the display that it's on this CYD. Getting the touchscreen to work is harder, but fortunately there was someone from Germany who actually basically did the hard part of that work. So basically you just search for display driver.py for the CYD, and then you get the resource, and you can just use the code that he made available. And getting batteries, you have to power these things. It's very easy. It has a USB micro port. The newer ones have USB-C ports as well, so you can use those for running things. What I did for these devices, I just used a power bank and then drive them like that. So if you want to flash MicroPython plus the LVGL library onto the device, there are two ways to do this. One is using Tony directly. So this is the Tony interface for doing these things, for flashing something. Flashing itself is pretty easy as well. You just plug in the USB cable. Actually, the hard part is figuring out which serial port got chosen. So there's a drop down here that you can just open, and then it'll show you what's available, and you just select what looks kind of like the right one, and then you just try it, and if it says, okay, it's working, then it's working. If not, you just try the next one, right? This is on Windows. You can similarly do it on Linux as well. On Linux, it's actually easier. So my first attempt was using a Raspberry Pi for these things. And then I found that Windows just works as well. So basically, I just then used Windows for the development. There are pre-built versions of this combination available from Stefan Scholz. Stefan Scholz is the guy who also did the display driver thing. And you can just search for his name, and then he has a page there, and you can download the binaries for the combination. Trying to do this, trying to build them yourself from source is possible, but it's hard, especially because the current version of the LV port to MicroPython that you get on GitHub doesn't work. So it's broken at the moment. Right, so how do you develop these things? So of course, you need a development cycle, like you do for every project that you do. So the first thing is that you create a main.py. This is run when you reset the device. And then you upload the modules that you write using Tony, again via the USB cable. And then in order to start things, you simply reset the device. This is very important because the hardware needs to be reset if you change something and the device gets into some weird state, maybe. Let's say you have a traceback or something. It's a whole lot easier just doing a hardware reset than trying to do a soft reset. Unfortunately, Tony doesn't have direct support for this. It has support for doing soft resets. But for the CYD, you will typically get an SPI error when you do a soft reset. So the hardware reset will actually make things work. So what can you do to speed up development? Because, of course, putting everything on the device and then trying it out will usually take a longer time. So there is a simulator that actually works fully in the browser. So it's very much like PyScript. And they actually compiled the LVGL library and MicroPython for the browser and then made it available at this URL, simlvgl.io. And you can actually go there and then develop your code there and try it out. And you would see what would be displayed on the screen. And then you can take the code and then put it on the device and try it there. They also have a couple of converters available, which are nice because, for example, if you want to put an image on the device, you have to convert it into a raw format that's suitable for the display. And likewise, for fonts that you want to use on the display, you have to convert those as well. So those are the URLs for the converters. And then you just take the binary files and put them on the device using Tony again. So if you want to, you're running into some problem and you want to find some help. So there are various ways you can ask people or your AI chat agent for these things. Typically, if you want to help, if you want help from someone who's actually used these things and also run into these problems, it's best to just go to the forum. But of course, you can also just try to read the documentation about these things. There's lots and lots of documentation, but often the documentation doesn't answer your direct questions. So it's usually easier on the forum or Perplexity. Some caveats. Basically, this is similar to, for example, what you have with PyScript. So, like, where do you put your secrets, right? Because you have to put them on the device somehow, and the device usually then, you cannot just go out to the internet and get some secret information from there. You actually have to put the secrets on the device somehow. Even if you encrypt them, if someone gets the device and then reads what's in memory, of course, they will have the encryption key that you use to encrypt your secrets as well, and then can basically reverse engineer everything. So this is hard. Even though the hardware does support encryption natively, so you can actually use routines that are implemented in hardware, so it's fast, but still you have to put the keys somewhere, so you just have to be aware that secrets can get lost and, work with that. Also, what you often get is weird SPI errors or weird other errors that you cannot really identify or know how to fix them. So basically, you just do the hardware reset and then that's it. And connecting to Wi-Fi. The devices do support Wi-Fi. Connecting to Wi-Fi takes typically a few seconds, up to 10 seconds or so. So a lot longer than what you would expect. But all of this is a lot of fun, of course, right? So you just keep tinkering, keep experimenting, and then you can actually get something to work. So let me try that, if I can do it here as well. So this is a short demo. Yeah, this looks like this. It's like a really, really short talk, right? So I just did it because I wanted to show the like the visual effects that you can do on these devices, and specifically for the talk timer, I try to do something that is easy to grasp for the speaker. So the screen turns red, you know something you're running out of time basically, and then when you're done, then it starts flashing, right? So this is essentially the project, and then you have, as you saw in the beginning, you have this button down here where you can press, and then you can select the schedule that you want to use. It supports both static schedules, so that, for example, PyCon Italia would be a static one, but it also supports things like lightning talks, because lightning talks, they typically start not according to a schedule, they just start at a conference, and then you can just start the schedule, and then it will run for 5 minutes and then alarm everyone. So, how do you structure these applications? When I started, I put everything into a single module, and then every single time I had an iteration to try out, I basically then had to upload that module again. Now, the upload to the device takes a bit of time. So if you have larger modules, this is time consuming. So what I decided is I basically broke up everything into small modules, and then I just worked on the small modules and uploaded just the ones that I changed, so that makes things run a lot faster. Something that's also important is if you use async code, which you should on these devices, because I actually don't know whether threading works on these. They have 2 cores, so it might work. But I've never used threading with MicroPython, so I cannot really say whether it does work. Async does work, and that's what I use on the device, for example, to run the clock, to run the timer, to run the bar that you see here on the right. So that's great. The only thing that you have to be aware of that is when you start everything, you have to put the init kind of process into basically into a single module, and then you have to be aware that how things start and when things start, because typically what you do is you first set up the display and the hardware, and only then you can start doing the processing using the async loop. Oh yeah, something else I forgot to mention, UI elements have to be globals in modules. And the reason is the way that the binding works of the LVGL library that you have in MicroPython. It doesn't do garbage collection that well, right? So sometimes if you don't put the UI elements into globals, it can happen that LVGL still uses some kind of C interface, but the object in MicroPython is already garbage collected, and you get a crash. Right? So by putting things into the globals, you can make sure that they stay alive and won't get garbage collected. So this is some of the code. I just, did some copy-paste because it's way too long if you want to show it on a slide. But just to give you kind of like an impression of how it works. So let me see whether this works. I have to use this, I think, right? Yeah. Where's the dot? No? Okay, doesn't work. Anyway, so first thing that you have to do is configure the screen, and then you can set a background color, and then you have different widgets that you have to set up. You basically just create them using the LV module, and then you configure them. You set a position, you set a color, you set various things that you need for the widgets. You can stack widgets on top of each other. So, for example, for the gear icon, what I did is I basically first created a round button and then created the icon that then sits on the round button. So that looks nice. You have event handlers that you can hook up to these widgets. So this is very standard stuff. like in every kind of UI library. And then you can, deal with the events that you get there and do things. So basically, that's how the menu, for example, works. Some additional things that you have to do. If you want to load assets, for example, images, onto the device and onto the, use them in your application, you should make sure that you register system drives using LVGL. This is something that I had a hard time with initially, but then once I found out how it works, it was actually quite nice. The way it works is that LVGL then goes to the file system and then gets the data directly from the file system and then loads them into RAM in chunks. So you save a lot of RAM by doing this. The other approach would be to first load everything into RAM using MicroPython. You just do a standard open and then you read in stuff and then you put it on the display. But that consumes way too much RAM, and so you often run into issues. So using the file system drives that you can register is actually a very good thing, and then use LVGL to basically just make everything work on the display. Something that's a bit weird is that when you interrupt things, so the async loop, for example, the device still responds to, for example, clicks on the touchscreen. That's because it's wired up internally then to C code, and the C code keeps running, and so the callbacks still work. That's a bit surprising sometimes. And like I said, hot resetting the device is usually the best way to get things done. If you don't want to press these small buttons all the time, then you can also use this code here, input machine and then machine reset, and that will do the same thing using software. So you can use that in Tony in the console, and then you get the same kind of effect. Right, so we have 7 minutes 30 left. So let me just quickly go through these things. These are like a few extra slides that I put in there. This is what I already mentioned, building from source is hard. You need 4 things. You need the SDK, you need MicroPython, you need the C library, and you need the wrapper for MicroPython. And getting all of that working is not as easy as it looks. There are 2 wrappers for LVGL. One is called LV_MicroPython, which is the one that I used. But I used an older version of that, which still works. I tried to, compile everything from source now, but it's simply broken. It doesn't work. So then there is a new port that's currently in development. Doesn't quite work yet, but it looks very promising. So I guess in the future, then everyone will switch to LVGL_MicroPython and use that. The downside of that particular port is that you have to rewrite all these display drivers and stuff because it uses a different approach. Something else, RAM planning. Something that you rarely do in cloud applications, for example, because you have tons of RAM. On these devices, once you load MicroPython, you have 100 kilobyte RAM left to work with. And then if you want to additionally use the wireless driver in there, then you only have 65K left, provided you use the display driver with low memory settings. And so this needs a lot of trial and error to make things work. Like I said, loading images into RAM is not a good idea. You can work around these things. For example, if you want to use wireless plus the display driver, which display driver obviously you want to use. There are 2 things. One is use the low mem settings. I found that using a parameter called factor equals 8 works really well, and you turn off double buffering, so you save some RAM there. Or you use a different approach, which is something that I used on this conference badge thing here. You can actually do it like a 2-phase kind of application. So the first application that loads is only responsible for getting stuff out of the internet. And then that first application starts the second application, which then actually uses the data that you got out of the internet. Because you can store things on the flash drive, and it will persist when you do a reset. And the nice thing about the clock, which is why I have to have an internet connection here, because I want to use a clock on these devices, and it doesn't have a battery, so there's no battery backup there for the clock. you have to get a fresh data from the internet to set the clock every time you start it. And that's why I used what I used here to do things. So yeah, that's it. As always, keep looking at what you can find out there and try to learn new things. It's all great fun, and it's really a good experience doing these things and then getting something working that you thought would be hard to do. So thank you.
So now we have a few minutes for questions. I see we don't have any on Slido, so we'll just do it the old school way. And
Firstly, thank you so much for the talk. It was very, very interesting as someone who's wanting to get more into low-level hardware. My question is, when you did the demo with the talk timer, I could see that the screen was updating from the top to the bottom, and I'm wondering, is that a limitation of the ESP32 chip and how fast it can write data, or is that a limitation of the display module?
So yes, it's actually a bit of both. So the ESP runs at, I think, 240 megahertz on the device, but then you have to use the SPI interface to write data to the display, and you can the standard setting is using 40 megabits for that, so which is not a lot, and then when you see things update on the screen, it actually writes data to the screen using this interface, and so that's why it's slow. You can also see that over here. I think it's a bit tiny, but if I press this button, I get a QR code, yeah, and you can see that really pop up very slowly, which is why it's loading data from the flash drive in chunks because to save RAM. And so, yeah, you have to be aware of these things. Things run a bit slower than what you might expect from a phone, for example, yeah. But then again, the nice thing is that these devices actually run on batteries for the whole day. So if you have a power bank like this, it actually runs for 1.5 days constantly with a bright display that you wouldn't have on the mobile phone. More questions?
any more questions?
I've seen the CYD has some built-in sensors. Can you add more sensors to it?
So let me show you on this one. So there are, you see these, well, it's hard to see. Anyway, there are a few GPIO pins down here that you can use to connect external stuff. I actually don't know which other sensors are included in here. That would be something to figure out. But you can use these to drive external, like a temperature sensor, for example, or I don't know, humidity or something like that. And then use that information. Or maybe you can connect it to some IoT stuff that you're building, and then use the data and then display it on the display, or even upload it to the internet somehow.
Great, thanks. This will be a rookie question, but let me ask about MicroPython. So, is it easy to just get and run MicroPython on your PC, like for for unit tests for that code?
Yeah, MicroPython runs on notebooks as well. So they're it's not only bound to these embedded devices. So you can actually run it on your PC. You can run it in the cloud. You can run it in the browser if you like. You use PyScript for that. So it's very flexible, and it's tiny. So it's a really nice project.
Very nice, exactly. I'm afraid we don't have any more time for questions. If you have any more, I'm sure Mark would be happy to answer them outside. And thank you, and good job again.
I ask you, I've never used, I mean, when I do these kind of things, usually I use C. directly. And I've never used MicroPython. How hard is it to manage memory?
Sa. Vuoi sentire? Non è pulito. Vero? Guarda. Guarda. Questa non scarica più. Sai perché non scarica più? Perché questi non sono sui microfoni. Cioè. Allora. Meglio questo. Uguale, lo fa uguale. Peggio? Qui non.
Yeah, I was gonna ask if typing in the touchscreen is gonna be a mess, but if you do it from the computer, yeah, that's what I was like. Yeah.
Ce l'hai? Ce l'hai? Ce l'hai?
Okay, that was a great talk and many interesting topics beside this one, the MicroPython. Well, lots about that to talk, and also managing secrets in embedded. Did you have any contact from PyCon Poland conference?
No.
Okay, then I'm the first to say. Please consider putting your proposal if you would like to talk there, because that would be really valuable.
Yeah, thank you, but I think I'm just doing PyCon Italia and EuroPython this year, so
and that's enough.
And that's enough, yeah.
Okay.
So maybe next year.
Okay. Time gets free end of August.
Scarica più, cioè praticamente come ti metti tutta la massa della persona va in trasmissione.
Is that your adapter?
Magari gli va bene usare questo.
Dopo se ti trovo una soluzione, ma magari ti porto uno stand. Se vogliono stare a sedere.
Allora, lui vorrebbe uno di quegli stand appunto dove può, così può stare.
Ti recupero uno stand.
Con il laptop.
Sì, te lo recupero.
Oh, that would be amazing if we could. Hey, and this works. That's a good sign. Okay.
Sta in piedi, il laptop collega, Simone è andato a prendere uno stand, così può stare qui e utilizzerebbe il microfono dello stand. Ok, sì,
Oh, it might be helpful. Might cut it close.
I was wondering what this was. I thought it was something that PyCon Italia provided for us talk managers to.
No, I mean
let you know when to-
this is why I did this, right? Because it's actually useful
Very cool.
to have.
C'era basta, c'era anche in questa sala.
Let's see if this is long enough. I could probably do this too, even though it's a little awkward. I could try. If my arms get tired, I'll sit down. So we'll see. We got a couple minutes. We'll see. Oliver Roux. Roux. Like a street in France. That helps.
Posso mettere anche questo?
Oh, if I was holding it, I need to
Quello bisogna adesso c'è qualcosa. Perché io non so.
Will the video get me?
Yes, we just need to. But what I was thinking is I'm so sorry if this is only we can only get this and not the stuff.
Okay. All right.
You can do it. You need this a bit more.
Yeah. Sure. Cable.
Aspetta, che è successo?
Yeah, it's all right. I feel bad for the people in the back who can't see me, but well, from here, like.
I know. I was thinking if you can like stand for.
Yeah, but I might have to.
We do have this one.
Oh.
So you can use this one. I was thinking, and you can change the slides from here if that works.
Yeah, I'll give it a shot.
Okay.
Give it a shot. Test. Cool. Yeah. I would say it's an intermediate. Beginner to intermediate, and maybe some covering advanced topics.
Oh, you actually left it. Nice.
It's almost applicable to my talk as well, so it's good.
So just one thing.
Yeah.
At the end, normally we have 5 minutes for questions. Is that okay?
Yeah. Yeah, absolutely.
So we'll be showing you signs. So it's like -10 is like -10 until the QA.
Yeah, I've got 25 minutes and then 5 minutes.
That's it. Yeah. So
Timers
here
to the end of the 25 minutes.
15 minutes left.
Yeah.
Yeah.
All right. Hi. All right. Everyone hear me? Cool. With that, we can get started. I apologize for this. I thought I'd have a podium, and I didn't memorize all my slides. So when I look down and look back up at you, I apologize. My name's Oliver Roux. I'm a software engineer at Bloomberg in New York City, and I'm here today to talk to you about building robust embedded systems. Whether you want to build better home automation or the next Mars rover, I hope what we discuss today will help you build resilient software wherever it runs. But because it's 2025, a quick heads up before we dive in. much of the artwork that you see in this talk was generated with AI tools. While I'm a pretty good coder, I'm a terrible artist. But with that said, all of the writing, including what I'm saying right now, is entirely my own. Now with that out of the way, to get started, we should probably try to better understand what an embedded system actually is. Formal definitions of embedded systems will say something like this: a microprocessor system built to perform a dedicated function. That's a good definition and still very applicable. However, for the purposes of this talk, I actually like this comment on a Reddit thread regarding the definition of an embedded system. Vidicon31 says, I feel like it kind of depends on who you ask, but I would say that an embedded system is a device that contains a computer that the average person would not consider being a computer. And in this case, a computer would be a general purpose system built to perform a range of different functions. And by his logic, his or her logic, an embedded system is anything that the average person wouldn't consider one of these. So, a microwave, not a computer. A car is not a computer. And a thermostat is not a computer. And in the past, internally, each of these things would look quite different from a computer as well. They'd likely run on some constrained microcontroller or microprocessor. It might only ever run one version of software, usually called firmware for that reason. But today, things have changed. The internet is everywhere now, and compute power is laughably cheap. So today we have the Internet of Things. Our cars are lousy with touchscreens, and you can play Doom on your smart fridge. While still not operated like a computer, internally, many of today's embedded devices look a lot more like your PC. Your smartwatch, smart refrigerator, or smart thermostat are likely running an operating system very similar to your laptop or server. And if you run Linux, they might be the same. These sorts of embedded devices, the ones running a modern OS on modern hardware, are what I want to discuss today. Because these devices are not operated like modern computers, but have modern computers at their core, building and deploying them introduces a bunch of interesting hardware and software problems. And we should talk about a couple of them. Regardless of the device, it will need to be powered in some way. And the first issue we run into with power is availability. Anyone who's dealt with a flaky smart device will know that the #1 way to fix it is to simply turn it off and on again. However, modern operating systems don't always appreciate unexpected power loss. And even if the OS is okay, your software may not handle that well either. Beyond that, power consumption is another problem. Many embedded systems run on batteries, but even a modest embedded CPU can draw significant amounts of power. It's even a good idea for wall-powered devices to think about consumption as well. Our smart home devices might only draw a couple watts, but they can run all day long for years, which can quickly add up. Now let's talk about the basic building blocks of a modern computer system: CPU, RAM, and disk, also known as persistent or non-volatile storage. Modern operating systems are great at abstracting away the physical details of the underlying machine. However, while your code might appear to run the same on an embedded system, you can quickly run into issues if you expect the same performance as your typical desktop or server. Other than limited resources, CPU and RAM should be fairly transparent to the embedded programmer, but non-volatile storage can take special considerations. More often than not, an embedded OS is using some form of flash memory as its non-volatile storage. And as you may know, flash memory has a finite number of write cycles. So while it may not appear different from the OS's perspective, over the life of the device, the storage can quickly wear out, and run into issues. And this is especially relevant when the device is expected to run for years or decades and never had a lot of storage to begin with. Now let's talk about failure. While power cycling a device may be the easiest way to reset it, that doesn't really scale well. Instead, embedded software should be written in a fault-tolerant manner, always considering how to fail gracefully in every situation. Furthermore, the operating system must be properly configured to handle failure in our application as well. And if a device requires external connectivity, like Wi-Fi, Ethernet, or Bluetooth, there are even more failure modes to consider. While the low-level details of these protocols are likely taken care of by the OS, any connectivity can be very unstable, and our devices need to handle connection loss gracefully and predictably. These are indeed good considerations when designing software for any environment, but they can become even more critical when developing for an embedded system. And when there is an inevitable failure on your system, detection and debugging can be much more troublesome in an embedded environment. Logs for our desktop and cloud applications are often available in some form of logging console. But for a number of reasons, like connectivity, data usage, and storage, accessing logs on an embedded system can be much more difficult. Also, we must thoughtfully consider how our devices represent their current state to users, because they likely have limited methods of communication in that way. Beyond operation, your device likely requires specific configuration. Wi-Fi passwords, IP addresses, host names, application config, and much more need to be loaded onto your device for it to operate. We take for granted how easy this is on our PCs. But embedded device likely does not have the luxury of a monitor, keyboard, or mouse, and might not be located in an easily accessible place. And this process becomes even more cumbersome if you're managing a fleet of devices or your configuration needs to change over time. Another huge configuration concern is security. Embedded devices share all the same security concerns as other computer systems, but the risk can be exacerbated by poor or lacking configuration. There have been numerous well-publicized examples of embedded devices being compromised by old security vulnerabilities or simply default passwords. On top of that, physically remote devices are easier for bad actors to access and put your data at risk. And in the event of a vulnerability or your software changes, you need to find a way to deploy it. Deployment mechanisms for software are already numerous and complex. Add in the issues of fault tolerance that we just discussed, and this process becomes even more difficult and risky in an embedded environment. Now that we've touched on some high-level issues with embedded systems, let's go into a bit more detail and discuss some strategies to solve them. By no means will this be a comprehensive guide to building reliable embedded devices. By definition, embedded devices are usually designed with a specific function in mind. So every use case will have specific requirements. And this is a good time to mention that the title of my talk is a bit misleading. Little of this is specific to Python, and instead it can apply to any software you want to run on an embedded operating system. Nonetheless, I hope what we discussed today gives you some useful insights into your next design. To start, let's talk a little more about storage. Before we can talk about solving issues with embedded storage, we need to discuss some of the problems in a little more detail. As mentioned before, the software in your embedded system the storage on your embedded device will likely be some form of flash memory, like an SD card or eMMC. These devices are great. They're plentiful, cheap, and easy to use. However, they have a tendency to wear out over time if we aren't careful. The best way to avoid this is to thoughtfully consider how and when we write to persistent storage. One great example of this is application logging. We all love to litter print statements throughout our code. But if every one of these print statements ultimately ends up on your small flash storage, you can quickly run into issues. And the same is true for OS logs. This may seem like a simple problem to fix, but even the pros have made this mistake. Famously, in 2021, Tesla had to recall over 100,000 vehicles because of their onboard eMMCs were failing. The culprit? It appears significant application logs were written directly to storage, shortening their lifespan and ultimately causing failure. Another peril with storage, which relates to our issues with power and fault tolerance, is the danger of corruption when the power unexpectedly fails. Flash storage devices are complicated at a low level, and interrupting a flash operation can potentially corrupt a large block of your storage, jeopardizing the device as a whole. If you've used a Raspberry Pi, you may have heard of this before. This issue plagued the Raspberry Pi community for years, causing regular corruption and data loss. And while multiple factors were at play, unexpected power loss, insufficient power supplies, and low-quality SD cards were the main suspects. And beyond the low-level hardware, your embedded software needs to handle power loss as well. What if you lose power while in the middle of writing the main config file for your application? Simple problems like this could easily brick your device. There are many solutions to flash storage wear corruption, but my favorite is to simply avoid disk writes altogether by making your file system read-only. This is likely what many of your embedded devices already do, and it's the reason you can yank the power on your Wi-Fi router and it's no worse for wear. There are many ways to accomplish this, and it usually depends on your OS and hardware. For example, on the well-known Raspberry Pi, they make this super easy with something called an overlay file system, which is a feature that makes your file system read-only while appearing to make it writable to applications, except all writes are temporary and are only stored in RAM. And if a full read-only file system is not an option, another good strategy is to send noisy disk writes like OS logs to a temporary RAM-based file system while writing important, less frequently changing data to your persistent storage. Read-only or RAM-based file systems are great, but this strategy does have its drawbacks. Related to what we discussed about debugging, if you're sending your logs directly to RAM and your device loses power, all your logs are lost, and that can make it very difficult to diagnose issues. You should also consider mitigating storage and power loss issues at the application level. One of the best ways to do this is to simply use libraries that handle interruptions for you. When properly configured, file-based databases like SQLite usually include multiple protections against data loss in the case of unexpected interruption. Even simpler, if you want to avoid corruption while modifying files from your application, I usually do something like this. Read the existing file, make your changes, write the new file contents to a temporary file, and finally, rename that temporary file to the original file name. At least on Linux, file renames are generally considered atomic. So if you were to lose power during this operation, on restart, your application would either see the old or the new file, but nothing in between. And now let's talk about fault tolerance, a huge topic in itself, and not just relevant to embedded environments. It's always a good idea to develop our software to proactively handle any errors it encounters. As always, it's application specific, but here are a couple basic design patterns for you to consider. To start, let's discuss process managers. Because we're concentrating on embedded devices running on an operating system, it'll be the operating system's job to start and manage our software processes over time. However, modern operating systems are complex and offer a number of different ways to manage an application. You can use init, systemd, OpenRC, supervisord, Docker Compose, and many others. And your choice is probably application dependent, but my advice would just be to pick one and learn how to use it properly. Don't try to roll your own unless you really know what you're doing. I often pick systemd, mostly because I know it and it's available on most of the systems I use. Systemd has a million different options, but most applications can run forever with just a simple config. This config file tells systemd how and where to start our application, when to start it, and what to do when it unexpectedly fails. With just this, you can enable your software, your service, and know that systemd will take care of managing it forever. Now let's talk automatic fault recovery. While PCs and servers likely have UIs or consoles to reset them in case of error, embedded systems may not share this luxury. One simple pattern I like is that of a watchdog. In its broadest form, a watchdog is a mechanism that monitors your system for abnormalities and automatically takes corrective action. Often, that monitoring is just checking for responsiveness or connectivity, and the corrective action is simply a software reset or system restart. It might not be possible to foresee every way that your software can fail, but if you can find some basic conditions that define the liveness of your software, you can have a relatively simple watchdog, monitor those conditions, and reset it if necessary. Now let's talk about fault tolerance and configuration. One of the riskiest times for our devices is during updates or configuration changes. Say you have a remote, inaccessible network device and you need to change its Wi-Fi settings. What if you send the wrong password? Or what if the new Wi-Fi network isn't available? For an inaccessible device, this could effectively kill it. When we build configuration mechanisms, it's always good to consider what could happen if you push a bad configuration and include some sort of fallback mechanism or at least some way to alert on it. Depending on your needs, there are many more strategies when designing for fault tolerance, and I'd love to discuss them after the talk. Regardless of how fault tolerant we make our embedded devices, they will always find new and creative ways to fail. When this happens, it's important that we have systems in place to monitor and diagnose those issues, let alone ways to fix them. For a lot of my home projects, my main technique for monitoring debugging is simply logging in via SSH and reading the logs. This can be fine for a small number of pet projects on your home network, but it's not advisable or sustainable for anything more. Logs and metrics are likely our first instinct when debugging issues with our software, but as we've already mentioned, saving logs directly to device storage is not always advisable, and only storing them in RAM leaves you blind in the case of power loss. One logical solution is to send the logs and metrics somewhere else, where they can be safely stored and analyzed. There are many good open source options for sending this data, and a ton of cloud-based solutions for collecting and analyzing them, including many with generous free tier options. The monitoring solutions we just discussed can work well, but they assume that the person debugging the issue will get value out of reading low-level application and OS logs. This isn't always the case. I can't think of the last time I wanted to read the logs on my toaster. Sometimes the best mechanism for communicating system state to the user is through physical feedback. Consider adding displays, lights, or sounds to your device. Something as simple as a single LED can often communicate enough information to a user to help them debug and fix an issue. Since our embedded devices are computers, but aren't operated like a computer, we should always consider more natural ways for the users to interact with them. And finally, configuration. At some point in our life, our embedded devices will need to be configured to perform the function they're designed for. However, configuration can be very complex, and there are a lot of considerations. Single-purpose devices may only need configuration once at birth. And for personal projects, there's nothing wrong with logging onto a device and running an install script. But for anything more, consider some form of automated software image building and provisioning. Not only does this ensure that the devices are configured and deployed consistently, it makes it much easier to scale. There are a couple good options for this, like Buildroot and Yocto, but all of them are too complex to get into in this talk. Many devices need to be reconfigured throughout their lifetime, and besides pet projects, manually modifying config files is not a realistic option. Instead, we should thoughtfully consider how to provide users with some form of configuration interface. Sometimes a simple on-device API that exposes common configuration parameters is sufficient. In other cases, it's better to include some form of UI. For example, most of our home Wi-Fi routers present a configuration web UI at a given address that allows us to easily configure device settings. There are many more considerations for device config that may influence your design, like potential for automation, idempotence, and fail-safes. And I'd love to discuss them after the talk. Beyond application config, our long-running devices may require software updates and security updates throughout their lives. These mechanisms are usually complex and very closely tied to the OS. The inaccessible nature of embedded devices only exacerbates this, and devices can go years without necessary security fixes. If you're doing small-time embedded work, I highly suggest choosing one user-friendly ecosystem and following their guidelines. If you're doing large-scale professional work, you have many more options with varying levels of customization and difficulty. So we've talked about a bunch of problems and solutions for today's embedded devices, but where does that leave us? Today, embedded devices are basically computers, even if we don't treat them like them. They operate much the same as modern computers and face the same challenges, but can carry a greater risk of failure. We discussed a lot of options, but by definition, embedded systems are purpose-built, so each application will be different. However, with thoughtful design, robust patterns, and a bit of paranoia, we can build devices that are resilient, secure, and easy to live with. And by embracing the constraints of embedded systems, we can learn habits that lead to more reliable software wherever it runs. That's my talk. Thank you.
Excellent. So we have some time for questions. Does anyone have any questions? Excellent. I think in the meantime, maybe you can expand on some points that you said you'd love to discuss. Feel like you wanted to get more into detail.
You're kind of putting me on the spot here. No, it would be better to discuss somewhere else, I think. I think something interesting, though, is that I followed a talk about embedded devices. But what I'm talking about is kind of uniquely different from this. Mark, right? What Mark presented on was much lower level, like running MicroPython as firmware on a microcontroller. And that's a different type of embedded system than what I'm targeting. So my talk was more about like running a full OS on an embedded device and the challenges there. There's a whole nother unique set of challenges when running on this sort of embedded device. It's often more difficult and simpler in some ways. More difficult because you don't get like the benefits of, say, the whole Linux networking stack, but simpler in that you're not running the entire wildly complex Linux kernel and you have to debug that. So I just wanted to mention that like I said, embedded systems are very application dependent, and it's a deep rabbit hole and hard to cover everything in one little talk.
Excellent. This was actually a really nice remark, for me at least. Very helpful. Okay, nice. So if we don't have any more questions, I'm sure Oliver will be happy to discuss later or outside. And thank you. Excellent job.
Thank you. I appreciate it. Mark, thank you for the dongle. Right here. Appreciate it.
Vai. Lo fa? Sì. Fa. Guarda che fai sentire? Ora no. Pronto? No, vabbè, meglio, Cambiamo il canale, mettiamolo sull'altro canale. Quale? No, no, cambia il canale. Hola, hola. Sì. Prova. Prova. Prova sì. 1, 2, 3. 1, 2, 3, 4. And 1, 2. 1, 2, 3. 1, 2, 3, 4, 5. Yep. Good morning. Bye. Good morning everyone. Hello. Yep. We just some drink. What do you want? Good morning. Good morning, yeah. Okay, very nice. Very, very nice. Good morning. Yep. Un po' io lo fa sempre. Sì, senti. Ma sentite fuori? No. Yeah. Okay, very nice. Hello. Hello everybody. Good morning everyone. So it's free. Here's Rick Lightsburg, 3 and Lightsburg. And Westburg to me lost here. Yeah. Yeah. It's okay. Oh, yeah. Is it work lines 3 and or Lightsburg? Yeah. It's okay. Very nice. Okay. Yep. Okay. Yeah. Good morning, everyone. In the Coleman 7, present Colleen and Susan also. All right. Who is the same choose man? Hope. The same all out man. in the cobalt state.
Potrebbe essere satura l'antenna perché siamo troppo vicini. Passamelo.
È vero? Oh yeah.
Dimmi se siamo lontano lo fa lo stesso. Da qua lo fa? Senti? Lo fa lo stesso. Ora lo fa? Non so che dirti. È così.
quello sì, effettivamente. Effettivamente sì. Due minuti iniziamo. Solo dire due cose organizzative prima, ma velocissimissime. Okay, I think that we can start. So welcome to this afternoon session. Before starting, I just have two quick announcements. The first one is that at 4:15 we have the lightning talks in Tortellini room, and then at 5:20 we have the Python quiz also there. Okay, so now we can start. Here with me there are Giulio Melloni and Andrea Calegari, who will introduce us to the world of AI, BI with Databricks. If you have questions, please use Slido, and the stage is yours.
Okay, can you hear me? Okay, wonderful. So, thank you everyone to be here. It's a pleasure and an honor for me to be here. And okay, today we are going into detail on the AI BI part on Databricks. So, it's kind of a different session maybe from the ones that you have seen, because it will be kind of codeless. Okay, so for the Python boys and girls that are fan of coding, it will be kind of surprising, because it's AI assistant, and so you will have a lot of prompt engineering. Okay, so it will be quite different from the typical one. So, okay. A little bit of myself. So yeah, I'm a solution architect in Databricks. I'm Giulio Melloni, and here with me there is Andrea, a solution architect too from Databricks. I've seen that I'm a solution architect in Databricks. Okay, no, it's not this, because I'm a solution architect in entity data. And okay, so going into detail, why we are here, thanks to entity data and Databricks that have sponsored this PyCon. And yeah, a couple of words on entity data. We are the 5th company worldwide for IT services. So of course, a consultancy company. And as you can see from Databricks, this is plot of the Forrester one. And you can see in the top right corner, Databricks, so is a leader in the data and AI part, especially for the Lakehouse part. Okay, so Lakehouse is the combination, as you can imagine from the word, the combination, the perfect combination between lake, so data lake, and house, so data warehouse part. So, what are we going to see? So the overview of the data personas, a little brief on the history of data analysis, and so we are going into detail about this. A deep dive of Databricks dashboard. You may have seen maybe Tableau, Power BI, or Click, tool like this. Okay, this is a new one, so inside Databricks. And also, we will see together how to consume this data using the natural language. Okay, as you can see from the bottom, there is a line. Okay, so it will be codeless. Okay, I hope you will enjoy this part. So that's the typical sentence that you may have heard a couple of times. Data is the new oil in 2025. So, okay, there is the gold, the platinum, and also the data, because data, from data you can have a lot of value inside the company, okay? You can predict the sales, you can, I don't know, do everything. So both on the machine learning part, in order to predict, have some analysis on the future part, but also on the descriptive part. So you can go also in the past and see, I don't know, using Power BI or Databricks dashboards, see what you have seen, what you have done, and so taking a look in the history in order to adapt your future. So as oil, data must be extracted, okay, and it's a important problem that we have nowadays, because we have thousands of rows of gigabytes of data, but it's quite difficult to get their value from this data, okay? So we have a lot of tools that can do this. Databricks is the most preferred one, I think, because it's combining a lot of things inside a one platform, okay? So it's the combination of the data engineering, the data analysis, and the machine learning part, all inside one platform. So thanks to this, you can, in an easy way, extract your data and gain some values, applying machine learning models, LLM models, and also, dashboards and data engineering stuff. Okay, so what is the main problem? Maybe this slide is a bit too much for our days, because you can see a lot of roles in the data world, okay? A couple of years ago, maybe you will have only the data engineer, the data architect one, but now you can see a lot of different roles. So from the business side, also from the technical one, okay, so for instance, there will be the orange one that are, the light blue one that are the emerging one, the roles, but also the blue one are the business one. So it's kind of a complication that we have nowadays, because we have too many people that takes a little part on this entire platform. Okay, it's quite difficult to have a communication between, for instance, a data coach, maybe sometimes, and an AI engineer. Okay, because there are two completely different roles. And so, what is the main problem? Usually, taking as an example, the data scientist and the data engineer write the code, but business analysts and data analysts do not, okay? So, a complication, because also data analysts and business analysts understand the business needs. So, one has the business see about the project and the problem, of course, and the other one, data science and data engineer, has the C on the tech part. And this is quite a problem, because the communication between these two different groups can cause misunderstanding and a lot of problems. So, how does technology support this communication between these two different groups? So there is the evolution, a little brief of history, as I told you at the beginning, on the evolution of the data analysis part. So at the beginning, 1960, you can see the first data analysis tool. It is not so, but it was used also for the data analysis part, and it's the common prompt. Okay, it's where started all the evolution. Okay, and here you can query your data. You can insert for sure directly SQL query, Python query. Okay, and you can analyze your data. So after this, 20 years later, we have the first table. Okay, so the relational table. You may have seen, may have heard about SQL, PostgreSQL, so a lot of database. Okay, so that's the main part of the relational database. So store your data with AC properties, okay, classic ones. Later, there is in almost 1990, okay, the worldwide common used tool for AI, for BI part, that is Excel. So as you know, it's the common tool. So everywhere you go, you will see Excel used for everything. Okay, so it's quite uncommon to see some company that it's adopting, I don't know, Power BI, Databricks dashboard, but it's quite common to see a lot of Excel files. Okay. Later in 2000, we have the dashboards. Okay, so Click, Tableau, as I've told you before. So here you can gain a lot of value from your data because you have also dynamic slicing about the data, and so it was a real game changer in the history. But still there is the problem. So AI, BI, the data analyst part and data engineer is kind of two different roles. Okay, so data analysts are doing this, and data engineer and data scientists are doing the back-end part, we would say. Okay, so now we are going to present this one, that is the solution about of Databricks, that is Genie Spaces. Okay, and basically it's combining the data with the AI, okay, using the natural language processing. So it's you will see that it's a completely different UI that is used with prompt engineering, okay, but you can query your data directly with the, I don't know, English or Italian words. And so everyone can directly access the data without having any kind of problem of knowing the code, otherwise knowing the business context. Okay, so for instance, you will have, you can give this to your AD of your company, and yeah, he can quickly ask to Jenny, okay, we will see this. Okay, tell me what is the topmost salary in my company. Okay, so also with Jenny, as you can see here, there are dashboards inside Databricks. So we have the problem of having a static KPI, maybe sometimes, that are evolving. And so with Databricks, you have not this limitation, because you have evolving dashboards inside, and so you can use also AI to tune your KPI inside this. So it's kind of a real game changer in the BI build of the reports, because yeah, you can change it with a couple of lines of English or Italian text. Okay. And okay, so before leaving the ball to my colleague, we will see briefly 3 different types of AI assistance during this. So the SQL one, it's okay, the classic, you may have seen Copilot, GitHub Copilot. So it's an assistant that helps you do the code, maintain the code, bug fixing the code. We will focus on the AI BI dashboards, so the generative part, as you can see here, of dragging and dropping, okay, and also on AI BI Genie, okay, and we will have a little demo at the end if we have some time. And okay, leaving the ball to my colleague. Thank you.
Hi everyone, and okay, so I'm Andrea, and now we have a look a little bit more about dashboards inside Databricks. And okay, I mean, dashboard, how can you share, how do you access your dashboard? That's like same classic stuff. You can send an email, you can send a chat, you can embed your dashboard inside your web page, your intranet, your SharePoint. It's something, I think, it works, it's good, but as Giulio said, it's a dashboard. So you have predefined KPI. If you want to show the dashboard to different business users, they may have different questions. And they are going to make you crazy because they will ask for 1,000 of filters, different colors, something that maybe it's hard to show. It's not easy. Maybe you have to do multiple dashboards. And this is just like classic dashboards inside Databricks. You can have the dashboard, you can have some filtering, and of course, again, you can extract some value from your data, but you have to prepare in advance for the business users. And of course, the dashboard always answers the same question, which may be good or maybe not that good. Of course, if you want to track your sale in a company, you always ask the business user is always asking the same question. How many pieces did I sell last year? And that's good. But what if he wants to ask any other question? That's where Genie comes in. So what's Genie? Genie is just the next step in the AI BI world and roadmap. So you have your data inside Databricks in the lakehouse. It's cheap data. It's very cheap to store and to query them. Perfect. You have your query. You have your data engineer doing the query. That's good. And you have your dashboard. So your data analyst created the dashboard. That's perfect. But now here comes Genie. So what's the difference here? Is that you can ask new question. And what you get after is that you get tabular and visual results directly after in the same page where you ask the question. And you also can provide feedbacks to Genie. So if a business user tries to ask some question and he sees some problem, he can highlight the things to you, maybe to your data engineering team, and after you can double check with him. Again, how do you access a Genie space? It's very easy. You can just send a chat to your colleague, you send an email. It's very easy, we will see it. The interface is super simple, and this is what I'm talking about. So you see, you ask a question in natural language. It supports also Italian. It works with English, other languages as well. You ask a question, and Genie creates for you an answer. And what is nice is that you can also see the code behind this answer. So what happens is that we use large language model to create a query from the question. You have your data Unity catalog, which is our data catalog, so we know a lot about your data because there are descriptions in the data, there are tags, and we analyze also the query that you did in the past, so we can pass all this information to the LLM to create the best query that it's possible to create. And of course, later you run the query directly in this place and you get the result. What is nice is also that you can do some quick action like visualize and create some visualization directly there. So for example, you ask Genie to visualize and it will provide to you, you remember here was the question, the total sale amount, and automatically it will create for you a chart. And with this chart you can share it, you can save it, you can keep it there later. You can also regenerate like the day after the code, maybe because you have new data, you want to see something if something changed. And I think this is very, very nice. So now we do some summary, and we can go to the demo. So I think it's best.
Yeah. So thank you, Andrew. And okay, just a quick summary about what we have seen quickly, because the demo is the most interesting part for sure. So, SQL editor, that's quite the common GitHub Copilot like, okay? So I assist on dev, it will be your daily copilot. It will assist you in the daily routine, daily jobs, okay, writing your code. Also for bug assistant, okay, so you will have a problem, you will ask to the SQL assistant. And it's also working with Python for sure, okay, so SQL both and Python. And it will bug fix hopefully your code. And okay, the other important, okay, AI BI dashboard, we will see this in the demo. And as you can see, it's a common typical dashboard. So as Andrew said, slice dynamically in the portion, a lot of different plots. So gaining very powerful insights on your data, and also you can interact with your dashboard, inserting plots using the natural language process. And the final one, that is Genispaces. Okay, so again, using natural language, you will generate plots. Okay, then we can go to the demo one.
Okay, can you hear me? Yes, I think so. Okay, perfect. So we talked a lot about Genie Room, and we're going to have a look at them now with you. So this is Databricks. I don't know if everyone has already seen Databricks. Do you know Databricks? I think so. This is like the interface of our data platform. We call it data platform just because we put everything in one place, so data engineer, data analyst, business user can interact and extract value from their data from one place, so that you don't have to stitch together a lot of services. And this is the Genie Room. So what I did here is that I put some data set inside the Genie Room. So you have to create it, and you put some tables inside. Directly, you choose the table with you just do drag and drop, and you select the table. Also, what you have is that you can add any instruction. So if you have like business-specific language, you can make the model know it, because usually there is like a slang inside a company where you call things in a typical way that it's very typical to your company. Of course, if you ask like ChatGPT and you don't provide any context, it will fail, because it's general intelligence. It doesn't know everything, and especially about your vertical and your company. So what you can do here is that you can add extraction. You can also add, if you want all your answer in Italian, for example, you can write it. And what also is nice is that you can provide some SQL queries and examples that should be used in some cases. So if you want to use to compute some rolling matrix, you can use some type of query. The example that I usually do is, if you want to count how many users do you have, like how many customers do you have in your company. If you ask the question to like 10 different people in your company, you will get 10 different answers, because people count things differently. So maybe someone counts some type of customer, some counts maybe some other type, some do all together. So what you can do is that you can create a query, and you can pass it to the LLM, and the LLM will know how to use the query, and will tell you that you used a query that it was already provided. So in this way, what you can do is that you prepare the query in advance, and all the company can use the same query to calculate some KPIs, or to do some analytics. Okay. So here I just ask a question to the model. This is a marketing campaign, so we put inside some fake data from a marketing campaign, and maybe you want to know which is the click-through rate, for example. And what is nice is that here you get some text telling you what the model did, but it's very interesting because you can see the tables that were used to query and to extract the data that you get here. So this is very important because it allows you to understand how the model created the query and what were the data used to provide you that result. Because of course, if you ask for marketing campaigns and you don't see the table campaigns, maybe there's a problem, you know. What is also nice is that you can also click on show code, and here what you get is the SQL that the assistant automatically generates for your user. of course, the business user is not going to care about SQL, but you, when you create the room, you are going to care and you want to check, to double check it, of course. And okay, so what happens is that the LLM creates the code based on your answer, on your question. And after that, as you know, Databricks is capable of querying your data for you. And so in this way, we execute the code without any problem on infrastructure, because we provided for you the infrastructure and the machine to run the code. So this is, you see, it can be also a very complex query. It can be something easy. And at the end of the day, the business user will get a table that answers his question. What is also nice is that you can have also here, directly here, inside the same chat, you also get to see a chart showing you what you asked. And what is nice is that you can work with the chart directly there. So if you want to see something, you have a bar here, and maybe you want to change the color because you like it in another way. Okay, as always, when you do something live, you have a problem, but I think it's the internet connection, but let's try if it came back. But okay, and of course, so you have a bunch of possibility to personalize your chart. Usually it works, but you know. And let's go to the next one. So of course, what you can do is ask more questions in the same chat, and you can also add follow-up question. It's very important that you ask a question and you do some follow-up, because you want to check the assumption and the data that the models give you. Again, behind this, there is a large language model. Everyone knows that it's not easy to make sure that it doesn't hallucinate, and there are still some problems, you know, with LLMs. Those problems are still there, but are mitigated because you can show the code generated, you can see the table that were used, and you can refine the question step by step. So here again, I ask for another question, for example, and what you get is, again, some other data. And here, again, you just get your chart. You can save the chart as an image, so you can just send it to your colleague if you want. But what is also nice is that you can also share the chat with some other people. So if a business user creates and asks some meaningful question, has some insights about your business, why it's not working the way it's supposed to be, or why is it going so good that year, that month, whatever, you can share it with some other people. And this is very nice, because in this way you don't duplicate data, you don't send around Excel files to your colleague via email, and after you don't remember where the Excel file is, when it was updated. So you see that it creates something way easier for you to work with. What is also nice is that you can monitor who and what is doing with the Genie room. So here I'm an admin user, I can see all the questions, and also it's possible to put a rating and to put a comment on the question. Maybe I can go back. Here you see you have the directly there. You can say, okay, it's not good, and you can say fix it, or you can say it's good, it was good, or you can request a review. So maybe a business user try to do some query and he finds a problem, and it will tell you, okay, I want to review this with my data engineering team. Maybe because the model did a wrong query, but also maybe because you have a problem in your data, because maybe there is some problem in your data pipeline, so you can review directly here, and you have a place where you can see everything. Other thing which is very nice, of course, I mean, you have history, of course, and you can also configure some, some benchmark, which is nice. So what you can do is that you can put some, I will show to you, you can put some question, and you can also put the SQL statement that you expect the model to generate. So what we do after is that we take your question, we pass it to the model, we take the SQL code that is generated back, we execute your code and the code that the model generated, and we check the data if they are the same. So in this way, you can, if you create like 10, 12, 20 question, benchmarking question, you can evaluate how good is your model. because it's always hard when you deploy something like this to say, okay, is it working? Are my users getting the right information? It's not easy to know because you should look at each answer, you know. And so in this way, you can have everything directly there, and you can run your benchmark whenever you want to, basically. So, and this is about our Genie solution. Maybe we can have a little bit of time to have a look at our dashboarding. Of course, this is more, you know, standard stuff. It's a dashboard. It works, I think, quite well with Databricks. And it's very easy to work with Databricks data because everything is in the same place. So you don't worry about like infrastructure, about permission, about networking, connectivity. Everything is managed from Databricks, and so you can create your dashboard and you can share them with your business user and so on. What is nice is that everyone logging inside here will execute the query as the user that see the dashboard. So if a user try to access a dashboard and, for example, doesn't have the permission to do some queries on some data set, you won't be able to do that because in Databricks we track and we execute all your SQL statement as with some permissions that can be set to the single user. So every user could see different things inside the dashboard based on the privileges that the user has. And the same things work with AI BI. And that it's what this works how? It's very easy. When you generate the code, we execute the code, but we execute the code with the permission that the user working with the Genie room. So what happens is that if you try to ask for like information or reserved information, you won't be able to query them. And this is not done by the LLM, so we don't just say to the LLM, don't do anything. We create the query, you will execute the query, and the query will fail because you won't be able to access the data. So, of course, what is also nice is that you can create a Genie room. So again, as I said to you before, you have to configure the Genie room, so you have to put the data, the tables that you want the Genie room to access, because you don't want to place a business user inside a Genie room that has all the data of your company, because it makes no sense. You have different personas. You want to create something more specific for a business user or some business user. You don't want to create something too complex. And what is nice is that when you create a dashboard, you can also, with some click, you can also create directly a Genie room based on the data that are in the dashboard. And that is very, very interesting, because in just a couple of clicks, you can create a Genie room that can help your business user, and it can also help you to reduce your workload, because in that way, the business user can try as much as he wants by himself. You don't have to create for him all the dashboard, all the queries, and all the charts that he think he may need, but sometimes you don't know beforehand. So I think we have some time for question. If you have any question, please.
If you want to also have more, 5 minutes.
Yeah. Okay, good. So yeah, just to sum up, maybe adding some tips. There will still be data analysts in the world, so it's not a replacement of a role, this, for sure. But this is an improvement, okay? Because, for instance, the AD of the CIO of your group, of your company, won't bother you anymore, asking you, okay, how many products have we sold this year? Okay, he can go directly here in Genie rooms. He can ask, using English, Italian, whatever language you want, and he will get his information, okay, without offer a data analyst, a data engineer. Moreover, for a tech person, it's an improvement, because for sure, you will have something to start with, okay? It won't be a white paper, as you can open Power BI and you will see the white paper that you will have to add visuals and bar plots, okay? this is an improvement because you will have something to start with. Okay, so okay, I got this data. Now create me a dashboard. Okay, or in Genie maybe give me some bar plots about this and this. Okay, so it's a starting point. And just a remark on how is it done. So this is done thanks to the Unity catalog that is present in Databricks. So first of all, you have to have the data that are cleaned and also well formatted and well cataloged. Okay, so I mean, as you can see here, it's all based on Unity catalog in Databricks. So Genie in the the dashboard is taking the value from what you are adding to the column name, to the comment. Also, you can create this with using the AI assistant of Databricks directly. So, for instance, if you name a column like I don't know, GPR with an acronym, it won't work so much because it's kind of a not comprehensible word. Okay, but if you insert some comment explaining why it's called column and campaign ID, campaign name, what is referring to, okay, this will improve for sure the Genie performance and the efficiency. And okay, that's all in order to sum up. So at the beginning we said, okay, okay, why we can link and how we can link the data analyst to the data engineer and also the business people to the tech one. Okay, that's kind of a way to do this because business people can directly query your data and also the tech people will get something to start with, also on the BI part. Okay, thank you.
So thank you, Giulio and Andrea. We have a lot of questions. I hope that we have time to respond to every question. So the first one is, I need to describe table to use Gene. How much table I can use in Gene? How to observe the performance? So it's more than one, just in one question.
Okay, so you don't have, it's not mandatory to put some comments in your table, but as Giulio said, you are sending what the LLM behind this. What does it know? It just knows what you provide to him, to the model. So what you should do is that you should put as much context as possible in your columns, in your comment of the table. Also here, maybe I show to you here, you can put some tags, you can put some primary keys. In this way, the model will better understand the relationship between your data and how to combine those tables in order to make your query work, Because if you don't provide enough context, it will work, but maybe it will fail. And here we can go back to the question, how can I monitor my performances? What you can do is that, of course, you can set up a recurrent meeting with your business user to check how it's going. You can also, as I showed to you before, you can also work, let's go back to the Genie room. You can also have some benchmarking and do some, you see here, some benchmarks. So you, as I said, you write your question, you provide the SQL query that you expect the model to create, and after we do some benchmarks. So we try the question, we send the question to the model, and we see what happens. So if you can do this for like 20, 30 questions, and you see like 0% performance, there is a problem with your Genie room. If you see 100%, you can build up your confidence and go to the business users. After you open up the dashboard to a couple of business users, maybe the most skilled one, and the one that wants to try something new. If you get positive feedback from them, maybe you open up to other 10 users, and you go on in this way. Last question, I think, was how many tables I can put in. There is no like a hard limit, I think, but I mean, you try to build a Genie dashboard as an extension of a Genie space, as an extension of your dashboard. So you won't put like 1,000 charts in your dashboard because it makes no sense. It's too much. So I should advise you to do something like that. So just the data that you think are needed to answer your business user question.
Okay, thanks. The second question is, do the natural language question get processed in situ, or they get sent to a third-party API?
Can you repeat it? Sorry.
Yes. So, do the natural language question get processed in situ? That means there.
Okay.
Or they get sent to a third-party API?
No, we work with a third-party API. There is an LLM behind this, and of course we send this data inside the region when you are, so you don't have to worry about data protection, data transit. So if you are in Europe, your data stays in Europe. If you are in the US, your data stays in the US. So that kind of part, it's not a problem for you. And also we manage the model behind it. So what we do is that centrally we change the model. We could change the model. We don't change the model every week or so because we change the answer. But it's something that we do on our side. So you don't have to worry about changing the model. Keep up with new model. There is a new model every couple of weeks. So you don't have to worry about that.
Okay, always related to the model. Which model is behind the gene? And can you choose your model?
No, you can't. As I said, it's we did this to make it easier for your team, your data engineering team, and your business user to work with. Now, if you open up like Perplexity, if you open up like GPT or Claude, you have a bunch of different models. You can't expect your business user to know if it's better to use GPT-4o or GPT 4.1 Nano. He doesn't know. He doesn't know about that part, and he doesn't care. And so we try to do this as simple as possible, to be honest. So that's why you don't get to choose anything behind that.
Okay, so always a bit related to this. How can you add contextual information to the LLM? For instance, the production line name can be referred to in various ways. Is there a way to enable a RAG?
Okay, this is not a RAG. It can work in some way, but it's not supposed to give you some piece of information back. So of course, if you put in the instruction, to add the context, you can put something in the instruction. So if, for example, you have a table that you always refer to as an acronym, you can say, okay, this acronym means this table. You can put it there. And also, as I said, you have to work with your Unity catalog. Unity catalog is your best friend inside Databricks. You have to work with it. And this description are sent intelligently from our side to the LLM model. So when you ask about the campaign table, the model will know that the campaign tables contain details about the marketing campaigns, for example. Of course, so in that way, when you talk about campaigns, and you put the data campaigns inside a Genie room, the model will already know that you are talking about marketing campaign. Also, in the comment, you can put like multiple names to refer to that column. Of course, keep it simple, because if you go with 1,000 word for a comment, you have problem with LLMs and lang and whatever, but that's like normal stuff.
Thank you. So another question is there just a model behind to do everything, or the process is splitted? For example, an LLM to create the SQL query and then another one to process the results and provide a human language response?
That's a good question. Honestly, I don't know. We should ask the engineers behind that. For sure, there is an agentic infrastructure behind it. So we generate, like 900% sure that we generate the code with an LLM, which is very good at doing that, and maybe we create this part with another agent. So of course, there are more agents behind this, but I don't know, because this is a service that we provide out of the box for you, and even if I knew I couldn't share with you all the technicalities. So, but yeah, for sure there will be some agent behind it.
Okay, and two last question. How can a company enable Gene inside Databricks? Is it free? And I will add also the other one because actually is related. What is the price model of Databricks? Is Gene a feature to add and pay?
Okay, so the business model in Databricks is very simple. For whatever you do in Databricks, you basically just pay for the consumption. So you spin up a cluster to do some query, you pay for the consumption of that cluster. We don't have licensing. You don't have to add like feature to the product. Everything is there for you. If you open up Databricks, Genie Room is there for you to try. What you pay is that as you pay something to generate the code, of course, and also you pay to run this query because, okay, we create the query, you pay a little bit to create this query, but of course you have to run the query. And so we provide for you a SQL warehouse endpoint, and you run the query against the endpoint, you get the result, we send the result back, and we provide to you the chart and the answer. But what you should be worried about is running the query, because if you run a query against a table which has terabyte of data, of course, and you want like to aggregate it, you will have to pay for that aggregation. But you don't have any external licensing or whatever. It's there for you. You can share it with as many users as you want. So if you want to do it with 1,000 business users, you can do that. It's not a problem. Of course, you will have like 1,000 queries, and you will pay for those queries. But that's the business model behind it.
Okay, the last question is, what guardrails you have from people making unrelated promotes?
Okay, so this is a model that works only against your data. If you ask how to cook a carbonara inside here, it's not going to answer to you because it's not related to text. So there are some guardrails for sure. We can try it. How can I? Of course, now it's waiting. You can try. You can ask a question, and we'll tell you that it's not relevant. You see, this is not a question from a business user. We are talking about business campaigns. We are not talking about pasta. I'm not going to answer that. Said that, of course, it will work with your data, so you don't have all the problems about, like your GPT models that you ask question and you can get like unwanted results back or racist language or whatever, because this is intelligence, AI intelligence on your data and only about your data. So it's not a chatbot that you can chat about the weather or whatever. It will just talk only about your data. And that's the main answer, yes.
Okay, thank you again, and we have time to change room now. Thank you.
Sono stati velocissimi.
Super interessante.
Sì, poi io stavo sudando perché ho finito le slide e ci ho messo due.
Ok, direi che ci siamo per questa nuova talk. Ora Tommaso Radiconi ci fa vedere come migliorare la nostra applicazione basata su LLM con Haystack, Llama Index e LangChain, mettendoli a confronto. Grazie Tommaso.
Allora, sì, come già detto nell'introduzione, l'idea sarebbe quella di dare degli spunti, quantomeno non voglio essere, come dire, completamente, cioè, do la mia idea di come mettere a confronto dei framework orchestrazioni, in particolare ne ho selezionati questi tre, ma diciamo come intro dico che appunto è una visione parziale, sicuramente ce ne sono molti altri che stanno ora nascendo. Comunque mi presento, sono Tommaso Radicioni, ho fatto un dottorato in data science alla Scuola Normale di Pisa e da 3 anni lavoro in AI No You e mi occupo di applicazioni basate su RAG. L'idea che di questo... Aspetta, scusate. Che succede? Ah, ecco, ok, scusate, si era bloccato. L'idea di questo talk nasce da la PyCon dello scorso anno, questo sono io che presento con la stessa maglietta tra l'altro ora che ci penso, un'applicazione chiamata Ragtime che si basava tendenzialmente su appunto l'utilizzo di Haystack per creare una RAG. Era uscito da poco la versione 2.0 di Haystack, era un modo per sperimentare, per vedere cosa cambiava rispetto alla prima versione, diciamo, della libreria. Ad un certo punto, parlando, come sto facendo adesso durante il talk, dico, cioè per scusarmi del fatto che ho utilizzato Haystack e non un altro framework di estrazione, ho detto sarebbe bello metterli a confronto, quindi ho presentato io stesso un talk su questo e ora ve lo ascoltate perché è stato un modo per me stesso per capirlo, perché quando leggi le guide appunto Haystack versus Llama Index versus LangChain ti ritrovi con, non so se avete mai cercato questa cosa, io l'ho fatto, degli articoli su Medium che tendenzialmente dicono questo va meglio per mettere in produzione un'applicazione efficiente nel retrieval, questo invece è efficiente in un altro ambito, sempre di applicazioni LLM based, però senza dare dei numeri o senza dare un'idea del perché. Quindi ho cercato appunto di sopperire a questa mancanza, secondo me, con un talk su questo tema. Brevissima introduzione, giusto perché così siamo tutti, come si direbbe in inglese, on the same page. Che cos'è un framework d'orchestrazione? Un framework d'orchestrazione è praticamente una libreria che si occupa, quindi un framework che si occupa di costruzione e gestione di applicazioni basate su LLM. Semplicissimo. Perché sono nate? Sono nate perché nel tempo, in questi ultimi anni, non solo i large language models, ma anche i loro utilizzi in applicazioni sempre più complesse, sempre più anche variegate a livello di task, a livello di user, a livello anche proprio di tipi di servizi che voglio utilizzare per ampliare l'utilizzo di un large language model, è aumentato esponenzialmente negli anni e quindi serve un framework che al suo interno non solo ha possibilità di chiamare questi LLM, penso appunto a Llama, modelli Llama, modelli di OpenAI, modelli di Anthropic e così via, ma anche tanti altri servizi esterni che possono essere utilizzati come una sorta di coltellino svizzero che tu utilizzi all'evenienza quando ne hai bisogno, per tutta una serie di funzionalità vastissime, cioè penso a moduli che fanno embedding, moduli di indexing, moduli di retrieval e così via. Quindi, mettendo insieme tutto questo, quello che ottieni è un workflow complesso che a partire da una query magari di un utente, quindi un input molto semplice, ottiene facendo tutta una serie di operazioni elementari, ottiene un output generativo, tendenzialmente appunto quindi basato su LLM per l'utente finale. Iniziamo dalla descrizione di queste 3 librerie, brevissimo, per dare anche un'idea dei concetti di base che stanno dietro ognuna di esse. Haystack è un framework sviluppato da Deepset, è composto da un core principale che è suddiviso a sua volta in dei moduli funzionali. Questa una struttura che riflette poi anche l'architettura stessa del framework e i suoi componenti. Diciamo, il vero core di iStack sono le component e le pipeline, quindi la componente è un blocco funzionale che ha un metodo run, questo diciamo la più semplice definizione di component. La pipeline è appunto un workflow di components che non è nient'altro che un grafo direzionale, cioè tu unisci vari componenti, ogni componente ha un input e un output, messi insieme danno appunto una serie di operazioni semplici che messe insieme creano appunto quel workflow complesso di cui parlavo prima. Il document store, che è un'interfaccia al database che si utilizza poi tendenzialmente in applicazioni di RAG per interrogare appunto una base di conoscenza che tu hai già, e l'agent, che è nato, se non erro, negli ultimi mesi, comunque è una classe nata recentemente e che praticamente è una pipeline dietro le quinte che richiede la definizione di un chat generator, quindi un oggetto che abbia possibilità di utilizzare dei tool e utilizzare anche un LLM con una sua memoria e quant'altro, tool e tool invoker per l'utilizzo appunto di tool. LangChain, seconda libreria, nasce come framework, diciamo libreria a basso livello, ma si evolve poi in un intero ecosistema. Penso a LangSmith, LangGraph, tutta una serie diciamo di librerie, di interfacce che sono sviluppate nel tempo. Codebase anche qui si costruisce attorno a un core che è LangChain Core e ha al suo interno piano piano si sviluppano diciamo, applicazioni prima supportate alla community e poi che hanno vita propria e sviluppano questo nome LangChain trattino nome del provider. Diciamo, ci sono numerosi concetti chiave qui, quello diciamo, che lo rende famoso è il concetto di chain, quindi è una sequenza anche qui come prima la pipeline che abbiamo visto prima, sequenza di runnable, di funzioni messe in sequenza elementari che creano un workflow più complesso. L'agent e l'agent executor, qua abbiamo, lo vedremo poi più avanti quando metterò a confronto gli agent. Abbiamo una chain che è l'agente, che è associato ad un invece agent executor che non fa altro che occuparsi del runtime, che va a chiamare, mettere insieme, aggregare l'agent con i vari tool. Il tool, che a differenza di prima, il tool viene, non solo ha un suo schema specifico, ma è chiamabile sia dalle chain che dall'agent. Questo è una cosa che ho trovato interessante che volevo menzionare. La MyIndex, terza libreria di cui vi parlo oggi, nasce come GPT Index anni fa, si trasforma poi in Lama Index, non mi chiedete il motivo, non lo so, e è un framework qua che nasce con l'idea di creare degli oggetti molto potenti nel campo dell'indicizzazione, nel retrieval, e si sviluppa poi in framework che appunto di orchestrazione che ha al suo interno diciamo varie altre funzioni. Si forma attorno al concetto di Vector Store Index, che come default quello che fa è caricare dei documenti al suo interno, trasformarli in node e generare già l'indice nel momento in cui tu carichi da un vector storage context il tuo store. E oltre a questo un concetto molto importante secondo me è anche quello di query engine, cioè di base non è nient'altro che la trasformazione di una query semplice dell'utente in una risposta arricchita da documenti. Nella pratica appunto è molto vasto perché è un'interfaccia anche generica che permette appunto di effettuare queste query e di trasformare un query engine, anche un vector store può trasformarsi in un query engine, per dire. L'agent e il workflow invece sono un flusso, cioè l'agent è un flusso basato sui workflow, è un concetto abbastanza, diciamo, è un'astrazione, è un concetto abbastanza complesso, comunque è una serie di eventi che sono dei trigger tendenzialmente che avvengono all'interno del workflow che hanno lo scopo praticamente di azionare certi tipi di funzioni, stopparle e comunque appunto dare alla gente la possibilità di di ragionare in questi termini, cioè a partire da pochi eventi, cioè da un insieme di eventi semplici, poi creare un workflow più complesso. Passiamo un po' alle metriche di confronto, cioè a quello che appunto ho sviluppato come diciamo arena di benchmarking. Sono tre categorie di benchmarking, ma appunto questa è una scelta che ho fatto io, può essere criticabile, anzi magari nella sessione di discussione verranno fuori domande su questo. Diciamo, i termini di paragone sono tre. Il primo è quello dell'integrazione. Mi sembra fondamentale per un framework di orchestrazione il fatto che si integri con diversi servizi esterni, come si integra con questi servizi, come avviene lo sviluppo di integrazione all'interno del framework, e quindi sono partito da qua. Passiamo poi dopo a una descrizione invece delle performance più invece numeriche, che era un po' la ciccia che volevo quando andavo a cercare su Medium dei benchmark, cioè capire appunto mettendo su un apparato sperimentale quali sono poi i numeri di efficienza di alcune metriche di cui poi vi parlerò. Appunto, comunque l'idea appunto è quello di stressare gli orchestratori in condizioni sia standard che invece un pochino più resource consuming, e poi la terza, che è quella che mi sembra comunque rilevante, che è la complessità della creazione di un workflow. Cioè io, persona utente che mi affaccio per la prima volta a un framework di orchestrazione, vorrei innanzitutto avere della documentazione accessibile, ma poi avere la possibilità di capire, non dico a un primo sguardo, ma capendo dei concetti di base come funziona il codice. Partiamo da qualche numero per mettere a confronto così proprio numeri diciamo di base proprio sulle tre librerie. L'Unchain vediamo che a livello di star su GitHub e di fork è quello più popolare sicuramente, quindi ha una community, diciamo, questo mi porta a dire che ha una community vasta di persone che utilizzano l'Unchain. D'altra parte la MyIndex mi pare che per via del suo alto numero di issue aperte, con comunque meno della metà degli utenti che hanno messo appunto di fork e di GitHub starts, mi viene da dire che comunque è una comunità in espansione. Una comunità in espansione si vede anche dal numero di integrazioni che vi motivo un po' questo numero così diverso dagli altri, nel senso che le integrazioni per la MyIndex, l'AMA Hub, sono dei pacchetti preconfezionati di alcuni, diciamo, integrazioni sviluppate dagli utenti, quindi non sono tutte quante integrazioni a servizi esterni, per cui è un po' falsato questo numero, cioè vedete che c'è proprio uno spostamento di ordine di grandezza rispetto alle integrazioni di iStack o Langchain, 75-112 contro 775, e deriva da questo. Detto ciò, mi sembra che comunque in queste 775 integrazioni ce ne sono effettivamente tante di più, anche se mettessimo che la metà di queste sono diciamo sviluppate da un utente che poi nessuno lo utilizza, comunque è significativo questo, significa che c'è una comunità attiva quantomeno, mi dice questo. Gestione dell'integrazione, vabbè, chiaramente ogni integrazione ha il suo repository, il suo test dedicato, questo diciamo gli fa anche dare, come dire, lo possiamo chiamare integrazione una cosa che ha queste due caratteristiche, repository e test dedicati. E le differenze più rilevanti mi sembra che siano queste, cioè su iStack abbiamo anche qui un approccio modulare con un protocollo definito per ognuno, diciamo, dei document store e altre classi che ho definito prima. All'interno di questo protocollo vengono poi sviluppate delle integrazioni che sono contenute all'interno di questa monorepo chiamata iStack Core Integration. L'Unchain, appunto, come dicevo prima, ha un passaggio leggermente diverso, cioè se l'integrazione è sviluppata dalla community inizia ad essere l'Unchain Community all'interno di questa cartella e poi prende vita propria e diventa l'Unchain trattino nome del provider. Per la MyIndex mi sembra più o meno appunto un po' diverso, molto diverso, perché appunto vengono ospitate sulla MAB. Una cosa che volevo notare è che mi sembra che su LangChain c'è un'estensione delle astrazioni di base, mentre invece la MyIndex definisce solo le interfacce, mi sembra, almeno per quanto ho esplorato le due code base, e ogni integrazione poi invece fornisce le classi concrete che implementano poi le varie astrazioni. Questo po' la cosa che ho notato, che c'è in entrambi, cioè sia in LangChain che la MyIndex, anche in iStack, però la MyIndex è un po' più spostato verso l'astrazione dell'interfaccia di base. Allora, passiamo alle performance. Diciamo sono tre chiaramente le cose che ho individuato come le operazioni che all'interno di una applicazione LLM based vengono fatte da chiunque, credo. La prima è l'indexing, quindi la misurazione dell'indexing di documenti singoli o documenti inseriti in batch. Indexing, per intendersi, è l'operazione di trasformazione di un file in un documento contenuto all'interno del tuo vector store. Questo più o meno è la definizione. Gestione dei document è molto simile, quindi diciamo da questo punto di vista ho notato che non c'è una grossa differenza della definizione proprio dell'unità minima contenuta all'interno di un vector store, quindi tendenziale, anche perché quello è un document viene definito come una classe che ha un testo, quindi il suo contenuto testuale vero e proprio, e dei metadati che lo arricchiscono per poi diciamo le operazioni di retrieval, le operazioni anche di arricchimento, per esempio, della generazione e così via. La pipeline di indexing cambia chiaramente, quindi andrò poi a vedere le differenze appunto tra queste tre pipeline. iStack, vabbè, lo dirò adesso, lo dirò anche più tardi, però chiaramente si basa molto sul concetto di pipeline, e qui nell'indexing abbiamo una pipeline di orchestrazione di tutto il flusso, quindi per processing, embedding e poi appunto salvataggio del documento all'interno del document store. LangChain ha un index invece gestito direttamente dal vector store. La MyIndex è molto particolare in realtà, perché ho dovuto fare ho un po' barato qua, perché in realtà la MyIndex definisce l'indice nel momento in cui definisce la classe document store, vector store index, scusatemi. Quindi quello che fai è un update dell'indice che già esiste. Quello che ho pensato è comunque questa cosa in un'applicazione basata su LLM va sempre fatta, cioè tu quando definisci la prima volta un vector store index o in generale una tua interfaccia per il database non è che ce l'hai già così fisso e non lo puoi più modificare, devi comunque simulare una cosa che nelle applicazioni reali messe in produzione tutti fanno. Retrieval, chiaramente seconda operazione da mettere a confronto. Per chi non lo sapesse, appunto, retrieval è l'operazione di come dire, ricerca del documento a partire da una query testuale, e in questo anche qui abbiamo, diciamo, varie differenze. Per iStack è di nuovo una pipeline di embedding della query e retrieving, più altri componenti se si vogliono aggiungere per complessificare il tutto. In LangChain il retriever è nativamente asincrono, questo è molto importante secondo me, e supporta nativamente molti algoritmi di search avanzata, questa è una cosa trovato molto positiva. La MyIndex invece costruisce il retriever on top del vector store, e anche qui ci sono, diciamo, nativamente le configurazioni avanzate. Terzo e ultimo, diciamo, benchmark di confronto è quello delle pipeline, che misura quindi le pipeline di la performance della gestione e costruzione di workflow complessi, e qui, diciamo, abbiamo un po' senza che mi ripeto, diciamo, abbiamo le tre divisioni che abbiamo visto prima, quindi iStack che utilizza il concetto di pipeline, quindi dei componenti che vengono connessi tramite il metodo connect. È un metodo che trovo trasparente, anche se forse un pochino verboso, perché proprio definisci tutto il grafo con tutte le varie tutti i vari componenti e tutte le connessioni. LangChain utilizza appunto il concetto di chain, tra cui molte di esse sono anche già standardizzate, quindi questo permette effettivamente a un livello di prototipazione di farlo in maniera molto rapida, cioè vuoi costruire una QA classica, tu importi retrieval QA chain e ce l'hai già pronta, senza dover collegare niente, senza fare nulla. Questo l'ho trovato un buon metodo. E poi abbiamo appunto la MyIndex che si basa sulle query engine, che è un metodo leggermente più astratto e nulla, insomma. Adesso andiamo a vedere un po' le performance. Prima di passare alle performance vere e proprie vi volevo dire che tutto questo è contenuto in una repository che è accessibile, dopo vi farò vedere appunto come accedervi con un QR code. Le metriche raccolte, giusto, prima di passare ai risultati c'è quest'altra slide. Sono appunto le benchmark, sono questi tre principalmente, quindi latenza, throughput e concurrency. Ho messo la definizione per chi, diciamo, volesse rinfrescarsi la memoria, ma alla fine sono, mi sembra un po', ho scelto tre metriche che sono abbastanza standard quando si parla appunto di performance. Quindi risultati, quello che ho visto sulla mia macchina, questi appunto sono risultati molto da prendere con le pinze, perché sono fatti sulla mia macchina in locale, l'ho fatta girare più volte, quindi su alcune cose sono abbastanza confidente. Quello di cui sono confidente è questa slide, sicuramente, nel senso che sull'indexing in tutte le run ho visto che l'Unchain era quello che proprio, secondo me, ha proprio in maniera evidente delle performance migliori. Con iStack, che comunque riesce ad avere delle performance simili in qualcosa, ad esempio nel batch, però che non è mai, diciamo, non è mai il risultato che eccelle più tra i tre framework. La MyIndex probabilmente, proprio per quello che dicevo prima, cioè che nativamente non definisce, cioè l'indice viene definito nel momento in cui viene definito il vector store index, sull'update non è invece così forte a livello di performance. Su retrieval la situazione è un pochino più variegata, cioè anche qua i numeri sono molto vicini tra loro, cioè se vediamo appunto a retrieval di base passiamo da 0,4 a 0,5, che alla fine non è una cosa così devastante a livello di performance. Se la giocano, diciamo, la MyIndex e l'Unchain su questo parametro, mentre invece sulla pipeline ho notato che al di là della latenza di streaming, che è molto migliore nella MyIndex, notavo che in generale nelle pipeline che ho costruito con i tre framework, iStack sicuramente è quello che ha la gestione migliore a livello di quantomeno di latenza. Questo, scusate, non l'ho scritto, ma pipeline latency. Quindi, diciamo, sulle performance direi questo. Passiamo all'ultimo tema, anche perché manca poco. Documentazione e facilità d'utilizzo. Qui, diciamo, per numero di tutorial e di how-to, sicuramente la MyIndex vince a livello numerico. Ci sono 38 categorie di esempio, ognuna con decine di notebook al suo interno, quindi c'è documentazione a profusione. Però l'ho trovato anche un po' troppo, cioè ti perdi anche facilmente. Questo poi è una mia valutazione soggettiva, per cui prendetelo pure con le pinze. Mentre invece sugli altri due, iStack e l'Unchain, abbiamo un numero similare alla fine, di cui secondo me iStack, poi forse perché è quello che utilizzo meglio, mi sembra che l'accesso sia un pochino più intuitivo. D'altra parte l'Unchain è un pochino più approfondita, e nel README su GitHub ho trovato molto interessante il fatto che sia molto breve, però con tutti i link diciamo che ti permettono subito di navigare bene poi sul sito, cosa che ho trovato molto interessante. Come si costruisce un agente? L'agente si costruisce velocissimo, poi dopo su questo in realtà trovate anche sulla repo di cui parlavo prima, degli esempi di agent. Ho trovato iStack appunto con definizione di agente molto molto chiara e facile cioè molto chiara. Perché? Perché definisce un component tool che non è nient'altro che una funzione con un nome e una descrizione, e definisce l'agent nel momento in cui poi definisci l'agent, definisci anche la lista di tool e chiami il metodo run, che è quello standard, diciamo, di iStack. Quindi molto molto chiaro. Medio-alta facilità di utilizzo, chiaramente, cioè appunto mi sembra molto lineare. Complessità, chiaramente devi avere un po', cioè devi conoscere iStack e le sue componenti. Langchain molto chiaro e molto facile da utilizzare, questo proprio senza dubbio, cioè pochi import, hai anche qui una definizione di tool molto simile, quindi con la funzione nome e descrizione, hai un agente, importi questa funzione chiamata create tool calling agent e poi tramite l'agent executor di cui parlavo all'inizio riesci a fare l'invoke e a ottenere la risposta. Ho scritto media complessità semplicemente perché mi sembra appunto che questa doppia definizione di agent e agent executor non sia molto chiara, però appunto questi sono gusti poi probabilmente. La MyIndex, ultimo, mi pare appunto sulla complessità qua siamo un pochino più alta perché devi definire, è richiesta una classe per la definizione di tool. La classe eredita un metodo che è toToolList che poi serve per essere integrato all'interno dell'agent che viene importato in questo caso direttamente dalla libreria con un altro metodo fromTools e poi invochi il metodo per appunto runnare l'agent con questo chat. Non l'ho trovato particolarmente semplice, forse anche è una questione di mio gusto personale. Quindi, wrap up finale, non mi è chiaro qual è il migliore tra i framework, non credo, che probabilmente sia anche una domanda particolarmente interessante. Qua trovate appunto la repo di cui vi parlavo, con tutte, non solo le slide ma anche tutti diciamo, i benchmark che ho creato, potete runnarli, potete aggiungere anche diciamo, i vostri framework di orchestrazione che vi piacciono di più, ne esistono molti altri. Alcune considerazioni prima di chiudere sono tre, diciamo, su una libreria. Dalle analisi, diciamo, dal lavoro che ho fatto per preparare questa presentazione, Langchain direi che non solo è il framework più popolare, ma capisco anche perché lo sia, nel senso presenta le ottime performance, almeno per quello che ho potuto osservare, e mi è sembrato molto facile da utilizzare e da interpretare il codice. iStack per me è molto chiaro il codice, forse anche qui è un bias mio personale, ha delle buone performance, ma mi sembra appunto che da un punto di vista di performance poi pratiche, proprio sui numeri, a parte sulle pipeline, sulla gestione della pipeline, non eccelle particolarmente. La MyIndex è quello che io ho trovato, almeno a mio gusto personale, con il codice meno leggibile, tante integrazioni, quindi questo da una parte è estremamente positivo, dall'altra mi sembra anche un po' troppe, è anche difficile accedere alla documentazione, quindi non ho trovato, ho masticato diciamo difficilmente questo MyIndex, ma comunque è un framework molto potente perché è molto utilizzato ed effettivamente presenta anche delle buone performance. Quindi con questo chiudo, grazie per l'attenzione e per il vostro tempo e grazie.
C'è il tempo soltanto per 1 o 2 domande, quindi se volete potete farle. Visto? Vediamo subito.
Sì, ti viene in mente quali utilizzi, se ci sono degli utilizzi migliori per uno piuttosto che per l'altro di questi framework?
Allora, secondo me oramai a livello proprio di cosa puoi fare con ognuno di questi framework mi viene da dire che ognuno riesce più o meno a costruire qualcosa di molto simile, cioè a livello anche di classi poi si rincorrono un pochino. Inizialmente l'agent era stato definito da Langchain, poi è stato ripreso come concetto anche per esempio da iStack. Ti direi che qua la risposta dipende dal team di sviluppo, dipende anche dai gusti e dipende anche dal tempo poi che vuoi dedicare alla manutenzione. Per me appunto nel momento in cui vuoi fare una prototipazione rapida, utilizzare Langchain è sicuramente un ottimo inizio. Sugli altri due appunto non me la sento di dare altri giudizi, ecco. Comunque con iStack, io che utilizzo ormai da anni, mi trovo molto bene, molto stabile. Langchain mi sembra che si stia spostando molto per esempio sulla costruzione di agent su LangGraph, questo rende un pochino meno facile l'integrazione con cose precedenti, quindi ognuno poi arriva col suo costo. La MyIndex l'ho trovato appunto, come dicevo, meno leggibile come codice, ma nel momento in cui si vogliono fare comunque applicazioni su cui c'è una forte interesse rispetto a retrieval e l'indexing, effettivamente ti dà molte funzionalità già integrate. Quindi chiaramente ognuna di queste librerie secondo me viene con dei pro e dei contro che vanno valutati dal team di sviluppo.
Grazie Tommaso. Il tempo purtroppo è tiranno.
Sì, no, ma mi hai fatto anche game over? Ok, non me ne ero proprio reso conto, guarda, proprio ciao. Stavo nel mio mondo. Grazie. Dimmi.
Ok, ricominciamo con questo nuovo talk, dove Lorenzo Bisi, Lavelli e Giovanni Giacometti ci presenteranno come prevenire l'obsolescenza dei modelli ML con il caso Bioretix. Grazie.
Ciao a tutti, allora in questo talk vi parleremo di cambiamento, andando a riallacciarci al keynote di stamattina e vedremo come il cambiamento può impattare anche sui dati e quindi sui nostri modelli di machine learning. Prima una presentazione, sono Lorenzo Bisi, sono AI Specialist in Melecube. Melecube è uno spin-off del Politecnico di Milano che si occupa di consulenza in ambito AI. Con me ci sono Alessandro Lavelli e Giovanni, che è pronto per le domande a fine speech, che sono Machine Learning Engineer e si occupano principalmente dello sviluppo della soluzione che tra poco vi mostriamo. E questo è un po' l'outline del talk. Inizieremo parlando un po' della drift adaptation in generale, poi andremo invece un po' più sul pratico con uno use case, infine vi mostriamo un po' i dettagli della nostra soluzione, l'MLQ Platform. Quindi partiamo con un esempio un po' più astratto, quindi immaginiamo di avere un'applicazione di machine learning, per esempio una classificazione, abbiamo addestrato il nostro modello e siamo abbastanza soddisfatti delle nostre performance, lo mettiamo in produzione. Bene, dopo una settimana ci accorgiamo che le performance non sono più le stesse ma sono calate. Perché è successo questo? Il modello alla fine è sempre lo stesso, e beh, quello che è cambiato sono i dati, perché l'ipotesi che avevamo fatto, che è l'ipotesi un po' sottostante a tutti gli approcci di machine learning, l'ipotesi di stazionarietà, non era verificata, quindi la distribuzione dei dati è cambiata nel tempo. Chiaramente col passare del tempo questo può peggiorare, le performance possono continuare a calare perché la distribuzione dei dati cambia, quindi avviene un drift profondo fino ad arrivare a dei risultati che possono essere dannosi anche per i KPI di business di un'azienda. Facciamo qualche esempio invece un pochino più pratico. Il Covid-19 è stato un grandissimo drift per tantissimi modelli di machine learning, soprattutto per i modelli comportamentali. Immaginiamoci un modello che doveva prevedere quanto si sarebbe venduto un determinato prodotto in un supermercato. Beh, sicuramente con il panic shopping quello che è cambiato è stato che i consumatori hanno iniziato a fare incetta di tutti i prodotti che pensavano sarebbero finiti da lì a poco e quindi tutti i modelli hanno subito un drift pazzesco. Chiaro che il Covid è qualcosa che ci può sembrare estremo, in realtà i drift sono molto più comuni e avvengono tutti i giorni. Immaginiamoci un task di computer vision, dove per esempio devo tenere sotto controllo qualche tipo di processo in un contesto industriale. Beh, in questo caso un semplice cambio nell'illuminazione può andare ad alterare la percezione del mio modello di machine learning e può portarmi a dei cali di performance. Questo anche se ho un modello, per esempio, invece che deve regolare i parametri di un macchinario. Qui un drift che può avvenire è dovuto all'usura del macchinario, questa è un po' estrema forse, che chiaramente va a cambiare poi l'output finale del processo e quindi mi porta ad un drift. Vi faccio un ultimo esempio reale. E qui però vi faccio indovinare qual è il drift. Qui si tratta di un task di computer vision applicato allo sport. Alzate la mano se avete capito cos'è che non va. Esatto, qualcuno ha già capito. Questo è un software che centra la telecamera dove c'è la palla per seguire l'azione. Peccato che con queste condizioni di illuminazione ha scambiato la testa dell'arbitro per la palla. Quindi diciamo, i drift sono veramente qualcosa che può avvenire tutti i giorni. E quindi è molto importante rispondere a due domande principali: quando riaddestro il mio modello e quali dati utilizzo per riaddestrare il mio modello. Per farlo ci aiutiamo con una rappresentazione grafica, qui abbiamo rappresentato una linea del tempo, dove andiamo a dividere un po' i dati tra prima e dopo il deployment del modello. Tutto quello che è prima del deployment è il nostro dataset storico, tutto quello che è dopo il deployment sono i miei dati di produzione che abbiamo rappresentato con dei cerchi. Prima strategia di riaddestramento, non riaddestro mai. Beh, sicuramente la strategia più semplice è tendenzialmente quella più sbagliata. Questo perché spero di avervi convinto che i drift invece avvengono molto frequentemente nella realtà e nei contesti di produzione. Quindi non fatelo. Seconda opzione, riaddestro sempre. Sempre cosa vuol dire? Ogni qualvolta mi arrivano dei nuovi dati. Questa potenzialmente potrebbe essere una buona scelta perché mi permette di integrare continuamente le nuove informazioni. Attenzione che però il riaddestramento può essere costoso in termini economici e in termini di tempo, quindi potenzialmente in questo caso voglio cercare di centellinare i riaddestramenti che faccio. Un altro motivo è la stabilità del modello. Vorrei cercare di avere in produzione un modello il più stabile possibile, quindi se continuo a cambiarlo, potenzialmente il cliente potrebbe non essere troppo contento. Altra opzione, riaddestro periodicamente, quindi mi do un intervallo di tempo alla fine del quale riaddestro il mio modello. Questo l'abbiamo visto spesso con anche degli intervalli di tempo poco sensati, per esempio ogni 6 mesi, perché ogni 6 mesi non si sa. Quindi come stabilisco poi in realtà l'intervallo? Posso stabilire un intervallo breve, però chiaramente più è breve più rischio di ricondurmi al caso precedente. Posso prevedere un intervallo lungo, se è troppo lungo rischio di perdermi il drift e quindi di andare a subire sostanzialmente gli effetti negativi. Un'altra possibilità invece è quella di riaddestrare a seguito di un evento di drift. Come faccio però a sapere che è avvenuto il drift? Beh, devo monitorare i miei dati o le performance del mio modello. Quindi ho bisogno di un approccio attivo, quindi di avere un detector che sia in grado di monitorare le deviazioni dei dati o delle performance. Questo è un approccio molto interessante perché mi consente di riaddestrare solo quando veramente mi serve riaddestrare. Passiamo ora alla seconda domanda che è quali dati utilizzo per riaddestrare. Anche qui, prima strategia, utilizzo tutti i dati a mia disposizione, passati e diciamo più recenti. È un approccio molto comune. Qual è il problema di questo approccio? Se c'è stato effettivamente un drift, allora io sto mischiando dati di distribuzioni diverse. Quindi di fatto il rischio è che non riesco a cogliere né il pattern vecchio né il pattern nuovo, ma il mio modello apprenda una sorta di via di mezzo che potenzialmente non è utile poi per risolvere il mio task. Può essere un modo per avere un modello robusto? Sì e no, nel senso che sì, in un certo modo il modello ha visto dati diversi tra loro, però se voglio fare un approccio robusto ci sono tecniche in realtà più avanzate per farlo. Altra strategia, utilizzo dati recenti. Qui l'ipotesi qual è? L'ipotesi è che i dati recenti in teoria dovrebbero essere più simili all'ultimo concept, all'ultima distribuzione disponibile. Questo è vero, anche qui però c'è il problema di andare a selezionare la lunghezza della finestra. Finestra molto lunga, mi riduco un po' al caso precedente, finestra breve rischio di avere pochi sample a disposizione, quindi devo scegliere questo iperparametro che è la lunghezza della finestra. Un'altra possibilità è quella invece di utilizzare tutti i dati a disposizione, ma di pesarli. Come li peso? Li posso pesare ad esempio in modo inversamente proporzionale all'età, ovvero i dati più recenti pesano di più, i dati più vecchi pesano di meno. È un approccio abbastanza simile al precedente, diciamo che però mi consente di recuperare anche dati magari un pochino più vecchi. Chiaro che anche qui c'è un iperparametro che è il fattore di sconto che applico ai miei pesi. Infine vi presentiamo un altro approccio che è quello di pesare i dati con il giusto peso, cioè tramite importance weight. Che cos'è l'importance weight? È una tecnica statistica che mi consente di assegnare un peso ai dati in base a quanto sono simili ad una distribuzione target. Quindi più un dato è plausibile rispetto alla mia distribuzione target e più pesa, meno è plausibile, meno pesa. Quindi abbiamo visto un pochino di approcci rispetto alle due domande, si possono combinare chiaramente per ottenere tutta una serie di approcci di drift adaptation. Noi ne utilizziamo uno alla base, diciamo, della nostra soluzione che si chiama IWDA, ovvero Importance Weighting for Drift Adaptation. Questo approccio mette insieme il monitoring adattivo, quindi monitorare in modo attivo alla ricerca di un drift, insieme con l'importance weighting, utilizzando come target di addestramento diciamo, i dati successivi al drift. Quindi isolo i dati successivi al drift, fitto la mia distribuzione e poi uso importance weighting per pesare tutti i dati. Questo in realtà è solo una parte della nostra strategia, che è un po' più complessa, ma non riusciamo a spiegarvela oggi purtroppo. In realtà la stiamo continuamente evolvendo anche grazie al finanziamento del progetto appunto FAIR SPOC 10 Italia, che ci dà appunto una mano. In questo vi diciamo un po' quelli che sono gli ingredienti fondamentali di questa strategia, che sono l'utilizzo di approcci di expert learning per capire come pesare modelli diversi che posso avere in parallelo, e l'utilizzo di tecniche di active learning, di cui vi accenna poi un pochino Alessandro dopo, che ci permettono di prioritizzare in modo corretto l'etichettatura dei dati. Detto questo mi fermo qui con la parte più teorica e lascio la parola ad Alessandro per la parte pratica.
Perfetto. Allora, tutta questa teoria quindi noi la mettiamo in pratica in un prodotto di cui vedremo dopo, e questo prodotto viene messo in pratica in un use case che è di Bioretics, che sono tra l'altro lì, quindi alzate le mani se volete. Qualsiasi domanda relativa allo use case nello specifico potete chiedere a loro, che sono un'azienda di computer vision. Lo use case in particolare riguarda la semantic segmentation di frutta e verdura negli impianti industriali. L'idea è quindi di scattare una serie di fotografie in due angolazioni diverse, in immagini RGB e profilo IR, e andare a identificare tutti quelli che sono difetti presenti nella frutta e verdura, per ovviamente scartare quelle che sono non adatte alla vendita. Ora, questo use case chiaramente è molto complesso dal punto di vista algoritmico, e qua chiediamo poi a Bioretics dopo, ma è soprattutto molto complesso dal punto di vista della gestione dei drift, perché possono capitare drift dovuti alla stagionalità, quindi avere frutta più o meno matura a seconda dei luoghi, ma questa stagionalità non è solamente inizio-fine stagione, ma soprattutto dipende dal clima, quindi con tutto quello che è il cambiamento climatico che possiamo immaginare, piogge, non piogge, eccetera, la frutta di fatto subisce tutti questi eventi. Possiamo avere nuovi difetti, quindi ad esempio pensiamo, non nel caso dei mandarini, ma ad alta frutta come la Drosophila Suzuki, che inizia a invadere il Trentino, quindi inizia a rovinare quelli che sono i frutti delle piantagioni, oppure l'estensione al modello in nuove aree geografiche, quindi i mandarini della Sicilia non sono uguali ai mandarini della Colombia. E quindi è necessario continuamente tenere aggiornato e controllare i dati, ma possiamo anche avere dati, cioè drift che sono dovuti non tanto al processo in sé, ma dati dal processo di acquisizione, quindi vibrazioni dovute alla macchina che lavora possono portare a modificare i setting delle macchine che acquisiscono le immagini, quindi magari avere problemi di focus che, diciamo così, si introducono lentamente nel tempo. Tutti questi problemi quindi vengono risolti attraverso un monitoraggio attivo dei dati. Questo monitoraggio attivo consiste nell'andare a monitorare diverse entità che compongono il caso d'uso, diciamo, di AI. Queste entità tendenzialmente sono l'input e la predizione, in quanto chiaramente non c'è nessuno che si mette a etichettare frutta buona, frutta marcia, se la frutta arriva a un frutto al secondo. E per quanto riguarda l'immagine, noi monitoriamo sia l'embedding, quindi la sua rappresentazione numerica, Però ovviamente monitorare solo l'embedding non è abbastanza, in quanto racchiudendo un'enormità di informazioni, sapere che è successo qualcosa non ci dice, non ci aiuta a capire che cosa è successo. Ed ecco quindi che monitoriamo assieme all'embedding anche altre metriche più domain specific, come ad esempio la luminosità, il contrasto, il focus o variazione del colore. L'insieme del monitoraggio di tutte queste metriche e quindi chiaramente l'allerting di un drift di una o dell'altra ci permette di comprendere meglio il fenomeno. Inoltre andiamo anche a monitorare quello che è il comportamento del modello attraverso ad esempio la posizione delle bounding boxes, attraverso il numero di oggetti identificati, perché se noi ci aspettiamo di avere un mandarino e poi ce ne capitano 3 in una foto, c'è qualcosa che non va, e così via con altre metriche. Addirittura se il modello fornisce anche predizioni a livello probabilistico, possiamo anche andare a monitorare l'incertezza stessa del modello attraverso l'entropia. Quindi in pratica cosa andiamo a fare? Andiamo a estrarre tutte queste quantità, applichiamo algoritmi di monitoraggio dei drift per ogni singola quantità e ogni algoritmo di fatto quello che va a fare è fornire una score che indica il fatto che quanto la distribuzione di produzione è simile a quella di riferimento, quindi quella che è stata usata per addestrare il nostro modello. Ovviamente abbiamo un drift quando si supera una certa soglia che ovviamente non decisa da noi come i 6 mesi, ma calcolata durante l'addestramento di questi algoritmi. Possiamo vedere quindi come in questo caso la variazione del colore ci porta a un aumento di quella che è la drift score e quindi di conseguenza l'identificazione del drift. Diciamo che monitorare l'embedding, monitorare tutte queste metriche forniscono parecchie informazioni su quello che sta accadendo. Inoltre abbiamo aggiunto anche un altro tool, un'altra analisi dei dati che ci permettono anche di comprendere meglio qual è che è l'evoluzione stessa di questi dati, che è attraverso il dynamic clustering. Quindi l'idea è molto semplice, facciamo clustering, ma questo clustering non è uno snapshot in un certo istante di tempo, ma viene aggiornato e vive assieme ai dati. Quindi l'idea è che queste tecniche che abbiamo sviluppato permettono di comprendere se ne nasce un nuovo cluster, se un cluster si divide in 2, se 2 cluster si mergiano, se ricompare un vecchio cluster, e quindi siamo in grado di tracciare, come dire, la storia dei nostri dati e anche quindi di identificare magari dei trend di transizione, anche quindi per prevenire potenzialmente certi drift. Quindi in questo caso possiamo vedere la presenza di 2 cluster di mandarini, la comparsa di un terzo che sempre in variazione colore e infine poi la comparsa di un altro, eccetera. Ora diciamo che abbiamo trovato il nostro drift, abbiamo meglio compreso cos'è accaduto, dobbiamo aggiornare il nostro modello. Ovviamente, in questo caso specifico, la label non arriva assieme ai mandarini, ma dobbiamo etichettare, quindi, o meglio, i nostri amici bioretici devono etichettare i mandarini. Siccome, come sappiamo tutti, il labeling costa, ovviamente non possiamo etichettare tutti i dati che abbiamo a disposizione, ma dobbiamo scegliere un budget, quindi scegliere una quantità di dati da etichettare, e questa scelta può essere randomica oppure può seguire anche dei criteri per massimizzare l'informazione che noi estraiamo dai nostri algoritmi. E l'idea quindi è di andare a applicare tecniche basate sulla diversity da un certo lato e basate anche sull'entropia del modello, al fine quindi di trovare quel subset che, dato un certo budget, ci massimizza l'informazione che abbiamo a disposizione. Tutto questo quindi rientra all'interno di MLQ Platform, che è il prodotto che noi stiamo sviluppando. MLQ Platform, diciamo, non è solo quello che abbiamo raccontato, ma un insieme di diversi moduli. Oggi abbiamo visto il monitoring, l'explainability, il retraining, l'active learning e il retraining. Abbiamo anche altre cose, ad esempio un link più specifico per quanto riguarda i costi di business di raddestramento, quindi capire quanto mi costa riaddestrare, quanto mi costa il modello con l'errore che ho attualmente, eccetera, eccetera. E poi una serie di moduli anche più specifici per quello che è il mondo LLM e testuale. arriviamo magari a qualcosa di più interessante per chi non è magari interessato all'AI, cioè l'architettura. Molto semplice, classica diciamo, architettura microservizi di un applicativo, tutta fatta in Python a parte il front-end. L'idea è che siccome è un tool di Model Ops, l'automatizzazione è tutto, quindi nasce per essere API first, ovviamente poi ha tutta la parte di front-end, ma è meno interessante perché è in JavaScript, quindi Python è questo. Che librerie utilizziamo? Allora, tendenzialmente PyDanti per tutto ciò che riguarda la gestione del dato, DTO, validazione, trasferimento e quant'altro. L'applicazione si basa su, cioè il web app su Fast API. Come tool di logging utilizziamo Loguru, che è piuttosto interessante perché ci permette di creare log strutturati e passare diciamo, parametri, quindi anche per un'analisi dei log a posteriori. DB basato su MongoDB, quindi Mongo Engine, diciamo molto più umano rispetto a PyMongo. E poi ovviamente dal punto di vista AI sono le classiche librerie che potete vedere. E per i dati invece utilizziamo Polars, quindi tendenzialmente siamo molto attivi su quello che è le nuove librerie su base Rust. Abbiamo citato su Polars, utilizziamo V, utilizziamo RAF. Stiamo monitorando TAI giusto per capire quando ha una certa maturità e quindi switchare. Per concludere, oggi volevamo anche parlare di ML3 Drift, che non è un nuovo film di Drift, ma è una libreria open source che abbiamo sviluppato e che stiamo sviluppando. L'idea non è quella di creare un'altra libreria di drift monitoring, perché ce ne sono open source, ce ne sono tante, ma di creare un layer standardizzato che permette l'inserimento di questi algoritmi in quelli che sono i maggiori framework di AI. Ora adesso noi siamo con i mandarini verdi un po' acerbi, vogliamo diventare maturi, quindi l'idea è di, chiaramente è open, quindi contributi, mettete la stellina, fate pull request e quant'altro. Qual è l'idea di base della libreria? Ora noi al momento abbiamo pensato di inserirci in quelle che sono le pipeline, quindi pipeline scikit-learn, l'idea di inserire un layer di preprocessing, diciamo tra virgolette, che durante il fit inizializza gli algoritmi di monitoraggio, durante la score predict applica il confronto diciamo, dei dati che riceve in produzione con quelli di reference e poi attraverso un sistema di callback può fare qualsiasi cosa, quindi creare un log, inviare un messaggio, fare raise error o quello che volete. Raise error non è un'ottima mossa, ma potrebbe essere. Adesso abbiamo anche Hugging Face, l'idea poi è di espanderci ovviamente Torch, TensorFlow e quant'altro. Concludiamo, quindi con questo QR code potete accedere al link tree che contiene slide, job position, quindi abbiamo anche aperte 2 job position qui sul sito della PyCon. Poi ci sono anche i vari link sulla platform stessa e altre cose, quindi sentitevi liberi di contattarci e ovviamente di fare domande su questa presentazione. Grazie.
Grazie. Se ci sono domande in sala.
Grazie innanzitutto per la presentazione. Le entità che monitorate, le monitorate in modo univariato, cioè una alla volta, o monitorate anche in modo magari bivariato, multivariato? Come...
Allora, diciamo che dipende, nel senso che le metriche tipo luminosità, contrasto, le facciamo in modo univariato, perché noi vogliamo trovare il drift di quella specifica metrica, di quella specifica entità. L'embedding ovviamente in realtà si tratta di un monitoring multivariato, quindi dipende. Nel caso tabulare ad esempio ovviamente facciamo sia monitoring univariato perché magari vogliamo trovare il drift di quella feature specifica, ma ovviamente nel caso tabulare o comunque quando c'è anche il target eccetera facciamo un monitoring di tutto l'input ma anche del concept, quindi input e output, input e prediction eccetera eccetera.
Grazie, avevo una curiosità rispetto allo, come dire, allo sviluppo iniziale, al training iniziale di questi modelli, perché trainate il modello, ma vorreste anche avere magari delle metriche, delle informazioni sulla detezione del drift e su quanto funziona il drift correction engine, non so come chiamarlo, no? Quindi in questo senso fate anche, come dire, un keyfold temporale e simulate i drift dei vostri dati in fase di allenamento o di validation, insomma, magari di tutta la pipeline?
Sì, in realtà, se ho ben capito, il tema è come tunare il detector, no? Quindi il...
Sì, o anche cosa aspettarsi dal detector, cioè perché ci avete fatto vedere la versione in produzione, no?
Sì.
Però per arrivare lì avete un dataset iniziale e quello è, no?
Allora, chiarisco un punto, l'idea diciamo del prodotto è quella di agganciarsi un po' ai morsetti rispetto a un modello che è già stato trainato da qualcun altro e tutto l'addestramento avviene dal cliente sostanzialmente. Quindi noi facciamo il monitoraggio e ti suggeriamo i pesi per riaddestrare il tuo modello, ma non facciamo l'addestramento. Quindi poi dopo l'addestramento lo puoi fare tu secondo la tua pipeline. Quindi se la tua pipeline prevede poi di fare cross validation, eccetera, per ogni riaddestramento lo fai. Se invece fai un riaddestramento con gli iperparametri vecchi, tanto per dirne una, allora fai in quel modo. Diciamo, su questo non diamo suggerimenti. L'altro tema è quello degli iperparametri dei nostri modelli, quindi tendenzialmente del detector. Per questo di fatto noi abbiamo degli approcci di validazione che applichiamo sul dato storico all'inizio diciamo, quando viene inizializzato il sistema sostanzialmente, e che abbiamo gli iperparametri migliori per il detector, da lì in avanti usiamo quelli.
In una delle slide in cui mostravate il drift, facevate vedere che monitoravate metriche di performance, no? Che dipendono dalla variabile target, esatto. È corretto? Sono variabili di performance che dipendono dalla variabile target anche?
Cioè, questa qui è la drift score di una specifica metrica, e in questo caso è il profilo colore.
Ok, ci sono delle drift detection sulla variabile target, che guardano la variabile target?
Allora, sì, diciamo che se c'è, sì.
Ok,
ovviamente.
Esatto, e la mia domanda era,
Sì,
nel
ok.
caso in cui fosse delayed, cosa fate?
Esatto, allora diciamo che dal punto di vista applicativo non è un problema, nel senso appena qualcosa arriva la monitoriamo. Quindi questo vuol dire che tendenzialmente diciamo così, il pattern è ricevere input e prediction subito, e quindi noi monitoriamo input e prediction subito, e quindi per input e prediction tutte quelle che sono le metriche estratte e quelle grezze. Quando ci arriva il target, allora monitoriamo tutto ciò che contiene il target, quindi il target in sé e la distribuzione congiunta input e target. Ovviamente in molti contesti è raro purtroppo avere il target, e quindi tendenzialmente ci si affida di più all'input perché si ha subito una risposta. Diciamo così, se troviamo un drift sull'input potrebbe non essere un problema per il modello. Già l'explainability cerca di fornire degli strumenti a chi ha realizzato il modello per capirci qualcosa. Ovviamente appena arriva al target allora si ha la certezza che anche il monitoraggio dell'errore stesso è un'informazione se il modello sta iniziando ad avere dei problemi oppure no.
C'è spazio per un'ultima domanda?
Volevo sapere se avevate previsto delle tecniche di reinforcement learning o qualcosa del genere, e nel caso come mantenere il modello stabile su questo.
Allora, questo è diciamo, quello su cui stiamo iniziando a lavorare. Sì, vogliamo sviluppare, per il momento non supportiamo reinforcement learning come task all'interno della piattaforma, ma supportiamo principalmente task di supervised learning sostanzialmente, però appunto il nostro obiettivo è iniziare a fare un po' di ricerca anche su questo settore, che è anche diciamo, una delle nostre expertise in realtà, perché il gruppo di ricerca dei founder di ML Cube ha questa tra le sue linee di ricerca, quindi insomma nostro interesse. Diciamo che non ci sono al momento tantissimi casi applicativi, e quindi per questo motivo abbiamo dato la precedenza alla parte supervised.
Grazie.
Grazie a voi. Sì.